All right, so here we are, week 16, and week 16 is all about Go. So I was looking at how many weeks we're going to be coding Go. We're going to be coding 4 hours a week every Sunday, again from 2 to 6 on Sundays. And I'm guessing it's probably going to take at least a month, which is, roughly 4 times 16 to 20 hours to get a good handle on even the beginning part of Go programming, especially if you're an absolute beginner. So there's a lot of things we're doing together. So the first thing I want to say before I even get into this is you are learning a lot of things at the same time. So this is one of the reasons I didn't do Go programming for the Boost before. I separated it out into a separate thing, and we would learn basic Bash programming, maybe a little JavaScript and Python, but we really wouldn't get into coding at all. Besides that, just so it could get you up and running on a terminal. And this is the first year that we've done Go programming. It's also the first year we've done like really deep diving into programming concepts and stuff like that. I mean, not computer science-y sort of things, but like the deep stuff. And that means that we're going to be talking about things like binary and, a little bit of what Turing complete and lambda calculus are. Not a lot, but enough to understand when somebody mentions it. And this is all on top of using tmux and vi and Linux from the command line and managing your virtual machine and all of that. So there's a lot of expectations here. So I have to say that right off the bat, I'm actually contemplating making this Boost, the Go stuff in its own playlist. So it will still be in the Boost playlist. But if people want to just do Go programming and they know all the other stuff, they don't want to be bothered by that, they can just go straight for the Go playlist, so that they can learn how to code Go and get going with it. Ha! Ha! So that is my only disclaimer for the day. So how are we going to learn Go? What's my method and everything like that? Let's talk about that really quickly. So we are going to be doing 100% project-based, you probably call it challenge-based, project-based learning. So there's going to be some theory, obviously, but it's going to be like interspersed with mostly let's make something that we would make just to test our chops on something. And the reason for that is so that you can repeat it all the time. This is how people learn in the wild. It's how animals have been learning forever. And it's like talkity talk, and then you don't really do anything, right? So, and I just want to say one more other thing, that there are certain academic circles that use the word practical as an insult, because people who deal with practical matters are applying their high-minded ivory tower theories, and they're the ones doing all the work, thinking through the problems and everything. And that's BS. It's absolute BS. I hate it. And that is not how I work. So that means that this style of learning is very, very messy. It's very messy on purpose. I talked about that on the first and second day of the Boost. But if you are just tuning in to Go and you haven't watched any of that, I have to tell you this right now. This is not a Go course. Okay. I hate the word course. I hate the word teacher. I hate the word curriculum. I hate, all of this stuff, because this is all so formalized that it removes the fun of learning and the experimentation and the exploration and the freedom to work outside the lines and find other ways to look at things, to learn something like a hacker would. And that's what I've always been about. I'm just reiterating things that I've been saying all along in the Boost, but I really want to say them again here now that we're talking about Go. So this is basically Go for hackers. So if you want to learn how, to write code like a hacker would learn how to write code, hey, there's the dancing Go from Tony Fung. That's what we're doing. So this is kind of like, I'm going to put here, go for hackers, and go for those, how about this? Go for those who learn like hackers. Right? So hackers learn by exploring and breaking things and finding other ways to do things. Go for hackers. No, they don't think we're actually hacking Gopher. That's different, right? But I should probably say that Go. I mean, we're going to talk about some stuff about why you should learn Go and all of that. But before we get into this, I am really, really torn. So I am actually going to ask the community. I don't know how many of you are there right now. I got to turn over my channel. But I have to make I have to make a question here. This is something, remember I said about not being formal. I am running these boosts exactly like I would run them if I were with you in person or with a small group of between 8 to 13 people. I mean, 3 to 8 people. And so I am going to do things that are going to seem very weird and unorthodox. Like, for example, ask you, hey, Mossy, ask you what you think. Okay. So this is your choose your own adventure right here. And I'm going to ask the group here. We can take an hour or less, 30 minutes, and get GitHub working. You're already supposed to be using GitHub for notes and taking them in Markdown, but we have not talked about that in probably 2 months. So it's really imperative that you have a code book. And we're going to talk about what a code book is. And for me, a code book is a GitHub thing. So when I do Go development, I'm already assuming that you already know, how to take notes on GitHub, that you know how to use VI, that you know Markdown, and all of these things. And so the reason that we did all of that before we got to this point is so that you could take really awesome professional looking notes in Markdown while you go through your own learning, because there's no textbook. You are going to be writing your own textbook, your own code book, which is going to have all of your own notes and your own examples. And you're going to be able to go to that and refer to it in a customized way. And you're going to organize it how you want to organize it. So, but in order to do that, you have to have it stored somewhere. And so we have been putting them up on GitHub. But one of the things we have not done with Git so far, so here's the question, is we have not done any basic, Git stuff from the command line. So I am going to do, the absolute minimum. I just decided because I just know that somebody's going to lose their code and I'm going to hear about it. So we've got to do it. Absolute minimum required Git skills. Okay. Now we are going to circle back to Git stuff probably after we do the whole thing. I don't know if I'm going to leave that for you to do, or we're going to do it together, but you have to know, you have to have someplace to put your code. And I feel so dirty. I almost did it. I almost convinced myself. I almost asked you just now whether you wanted to do it the dirty way, which is just make a directory somewhere and put it in there. Or the right way, which is you put it, you create a Git repo and then you put it in there and you commit it every time you do it. And then if you have to fall back to anything because you make a mistake, you can go back to it. And I mean, the commits are going to be messy. Everything's going to be messy. It's not a true knowledge about how to use Git and branching and all that crap. And I don't want to scare people away, but we're going to do the absolute minimum for Git really quick. Okay. And so that's going to be the first thing on the agenda here. And I went ahead and I started, it's not finished by any means, but I started porting something. Let me give you a link to it. HTTPS github.rdbxrob/challenges. Okay, so challenge project-based learning. Otherwise, I call it challenges. So if you've done any try hack me or hack the box, that kind of thing, that's what we're doing, except for I'm going to walk you through at least one way to do it. There's no best way to do it. I mean, a lot of these people are going to have like 10 different ways to do them, and you can go read about them. So this is how we're going to learn Go. So let me just show you. So, and then you can save your own challenges in your own code book or separately. I would put them in your own code book because then you don't necessarily have to make a new one every time. And so we'll talk about that. But if you want to go look at the challenges repo, you can go into challenges. So these challenges have been, they're not done, but I mean, they're done. They're just all in my SKILSTAK and they're in Python right now. And I've actually added a number of them. So let's talk about what challenges are. So learning, to me, sync notes via Obsidian with Git. Yeah, I have really negative feelings about Obsidian that are justified through objective use of Obsidian in discovering a bunch of problems. And we had a big debate about that when we talked about Obsidian and GitHub and Markdown. We are only going to be using Markdown, and we're going to be using true Markdown, not Obsidian Markdown, which is not standard. And I can't imagine anybody wanting to put their entirety of their their life into a knowledge base that's 100% proprietary and you have to pay for. So that's my complaint with Obsidian. It's very quick and dirty, but we don't have to, you don't need to worry about that. We're just going to use Markdown for our notes. Okay. And this is, again, I had to reiterate a lot of stuff from the beginner boost because we covered this like 2 months ago. We covered with Markdown. It was the first thing we did, how to do Git, how to put stuff. We're going to cover it really quickly, hopefully within 30 minutes so we can get coding. But it's super important for Go coding as well because most of Go depends on Git repos for importing libraries and stuff like that, including Bonsai, which we will use. I'm super excited. It's the first year I've ever done it. I finished Bonsai this year, and we'll talk about that. Okay, so these learning challenges, this is how we're going to be learning, right? And again, these are just suggestions. You can learn however you want, but this is going to be the basis of how we're going to do stuff. So this repo contains learning challenges. Challenges are written without any... they just define what needs to be learned and they cover the topics generally. Sometimes there's an overlap and I'm going to try to tag the different challenges with the concepts that overlap. So if you wanted to zoom in on something that covers something, this technique, by the way, is not unique. People have been doing this forever. Exorcism.io, which has a bunch of Go challenges that I don't particularly agree with, it's a great platform though. Is really great if you want to get behind that. In fact, Exorcism.io, I believe, is the official. It's now the official. What's his face? You guys remember this? Tony Fighter, remember? I think Exorcism was declared by the Go Developers Network, which is the biggest group of learning experts out there. I guess that's not it. Which one is it? What is it? Do you remember? They declared this as the official platform for all Go learning. And I was like, meh. I mean, it's fine, but why do you have to declare an official platform? And this is, when you go around looking for learning and Go, okay, so I probably should talk about the landscape of the learning landscape for Go. Let's talk about that. Let me make sure I get that on the list. We'll do an overview of learning landscape because it's actually kind of a problem. And we'll come back to them. I'm probably going to get hate mail for saying some of the things I'm going to say. I don't care. I'm going to tell you how I feel. Okay, so Go Exorcism. You know what? This is a part of that. So let's just leave that there. And again, I told you I'm very organic. I just let things come to my brain that are happening as they do. I do give a little thought ahead of time. And so let's go back to the challenges really quick. So Exorcism is like the challenges that I talked about, and that's what got me onto that sidetrack. So here's what they are. They're mini projects. The process is that you read about the challenge, and you kind of, for your own self, like figure out what you need to learn. You don't need me for this, by the way. I'm just going to go through it as if I was doing it with you, next to you. And that's how I do everything. I give people a shot at the challenge by themselves and they get stuck. I kind of, it's kind of like, I call it like, like when you're like weightlifting, if you anybody ever done bench press? I know it's not a popular way to exercise anymore, but in the old days, when you would do a bench press, which will really screw up your shoulders, so don't do it. But if you do a bench press, you have a spotter, and the spotter's job isn't to lift it for you. Anybody ever had a spotter who was always lifting too much and didn't let you push hard? Or the reverse? Somebody's like, yeah, look at you suffering down there, right? The best spotter when you're weightlifting is one who puts like 1 or 2 fingers on the bar, and all they do is just sense just enough to keep you pushing, right? That is a good mentor. That's the kind of person you want to learn with. You don't want to learn with somebody who's going to like do the whole lifting and then flex about how awesome they are and tell you to sit there and take in the knowledge, that they tell you, like Paulo Freire complains about in Pedagogy of the Oppressed. You don't want that. You want the person who's going to sit next to you, potentially working on their own project, maybe even their own version of the same thing. And then you're gonna work with them, and you're gonna be like, well, what did you get for this, or what did you think about that? And you're going, oh, and then you can like compare notes. And it just so happens you have more experience because you came first. It doesn't make you better than them. It doesn't make you smarter than them. You just have more experience. And anybody can be a mentor this way because everybody has a personality that works well with at least one other person's personality. So this is the true way of learning. This has been like the first 2 months of the boost, like summarized in like 10 minutes. but so that's what I'm talking about. So first of all, you're going to read the challenge. You'll notice right away that, and it talks about it down here, that the challenges are not written for any language. You can implement the challenges in any language you want. And I actually strongly encourage you to do that if you want extra. It's called a polyglot approach. It's when you learn 3. I actually started writing a book about this. We did C, Go, and Python. Actually, no, we did C, Go, Python, and JavaScript. And we did all of these micro mini projects, mnemonic mini projects together. I'll get to that in a second. So research what needs to be learned about and write it in your own words. And that's where your code book comes in. You need, I call it a code book for this. If you have a Zettelkasten or some way to take notes on GitHub or whatever your method for note taking is, it's fine. I'm not going to judge your method right now. I'm just telling you the ones that I prefer. My preferred way of taking notes is just to open up a Git repo, private or otherwise, and just put a bunch of stuff in there. I do recommend, however, that your repo for this be private, because you don't want your hello world to pop up in your search results by potential employers in GitHub. There's nothing wrong with that, but you don't want it to stop them from seeing your other stuff, right? So if you're doing a lot of commits to your Git repo because you're learning, right? And if your top green dot is always being filled up by your notes and your code book and stuff like that, then people might get the wrong impression. They might think that you're prioritizing that thing, that you're not working on anything else. Whereas you may have written like one really well thought out PR to some other project, and that's going to get pushed down in the list on GitHub. And so that's, hey, how are you? So that's my suggestion, is that keep your code book private. And then when you start to make unique, you'll start to, when we do all these projects are designed to give you ideas that you can riff on. So and this Learn with Leon does the same thing. So you'll find some ideas here that you can take and make your own, and then you can deploy that on your own, and it'll make you unique. You won't look like just another person doing X and Y tutorial out there. And that's what's going to separate you from everybody. That's what's going to show you have experience. You've been, thinking about things, and you can talk about it emotionally, excitedly. When somebody says, "Hey, what did you do? Why did you make this?" You say, "Well, I wanted a thing that does X and Y and Y." We haven't done the repo yet. We're going to talk about that. The challenges. So the challenges repo is just a list right now, but this is where I'm going to be fleshing out the requirement sheet. I started doing one at rwx.gg, but I'm kind of like I'm redoing it. So I'm in the middle of redoing it, but this will be the place to go. And I mean, if you want to see the old one, you can go to rwx.gg Langshaw. But I was in the middle of migrating from all of my Python code. This is going to get deleted completely, but it's the idea is that you have a set of requirements, and you go about checking it. There's no automation. There's no automated test validation. There's none of that. And I used to have that, actually, and I got rid of it. And the reason I got rid of it is because everybody's going to fulfill the challenge slightly differently. And there's no way, short of having an experienced mentor or peer look at the code and evaluate it, for that to ever be evaluated. No amount of AI, no amount of algorithmic, and I've done it. I wrote SkillBots. I wrote a huge library of regular expression matches. I wrote it and then it got really frustrating for people, because they were like, but I put the comma in the wrong place or something, and they would fail because they didn't match the exact perfect way to do it. And so get rid of all that stuff. And it also makes the entire edtech, educational technology integration for this kind of learning completely easy. Because now it's based on human beings, and because you've already decided to be 1-on-1, 1-on-2, 1-on-8, you already have the ability to give the attention that's necessary to those people. Those automated solutions and stuff are all designed to work with an extremely broken education system that sticks 400 people in a single class. And they don't work. They don't work, my friends. They work. If they work despite the system, not because of the system. So the way to have this work really well, and by the way, this is the way the Boy Scouts have been doing it forever, or the other scouting program, is you identify a mentor, a merit badge counselor in the scouting world. You set forward your learning plan, you work on it together, and they check in with you and see how you're doing. So that's what we're doing, okay? So experiment with different ways to fulfill the challenge. So and by the way, if this sounds familiar, so we have R, you have W, and you have X, and then repeat. That's where RWX comes from. Experiment with different ways to fulfill it, explore, research what needs, and write about it, okay? Read the challenge, research it, so read and research the challenge. Hey, Temin. So, where and how to learn the specific skills, knowledge, and abilities are up to the learner, because it's up to you. The most important skill you're going to get out of this is you're going to learn how to learn in your way. You're going to learn those command line search techniques that I told you. If you're going to use those if you want to, you're going to be able to go find resources that I may not have found yet. You're going to find your own newer resources of what I'm going to stick in front of you. Any person, the biggest problem with college education and other education like that is that they put things in front of you and they give you books that are like already 5 years out of date. So it's absolutely important that I give you a challenge, say, here's how let's fulfill this. And then we look together for the most recent, best ways to do that. But let me give you a good example. I'm going to stop myself because we're going to talk about the problems with the learning out there. And most of it's around 1.18. We're going to get to there. So anyway, then you get to decide your part of the learning process. You set up the plan, and I'm just here to kind of help you along. So the TLDR of this, which I should have said at the beginning, is the challenges are designed for you to read them, process how you would do it yourself, and then go off and do as much of it as you can on your own, right? Researching it on your own. Now, I am going to do that same thing. I am going to do the challenges, and some of them I put out there that I haven't done yet. I am going to do the challenges in that exact way. Okay. When I'm going to go, even if I know something, I'm going to go search it, and I can be kind of sitting next to you while you do it. So if you want to go to those things, if you want to do that yourself, if you want a kind of a guide to make you feel cozy and code next to you while you're doing it, and you want to kind of see my way, but I want to be really careful here because I do not want you to do it my way. I want you to do it your way, and I want you to maybe, learn the ideas as we're going through them, but I'm going to try to stop and say, okay, now do this thing, and now here's how I would do it. And this gets us down to the challenges, by the way. Well, we'll get back to that. Repeatable for self-assessment. All right. So, and then, so I want to get down to this one right here. So there's not, I put in the challenges saying there will never be a solution listed in the challenges. You're going to be like, well, how do I do this? This just tells me a thing that I could do. And like, oh, I need to see somebody else who did it. It's up to you to find those people, to make peer connections with people who have done it, who have Git repos, to put it in your notes and say, here's my buddy. He's going through this solutions as well. Let's look at all that stuff goes in your notes. It goes in your code book, and you can just add Artibix Rob, TV on Twitch. You can add it as well as one of the places to go to see here's how one person did these challenges. But I really, really want to encourage you to do collaborative community learning where you go and you compare notes with everybody else. That's how I did it at SKILSTAK, which I started in 2013. It was immense success, and I won't get into that right now. And people come out of it being really happy because they feel like they have a sense of ownership of everything, including Hello World, right? Well, this is how I did Hello World. Oh, that's cool. I hadn't thought of it. Or maybe they do it in French, or maybe we had one guy do the dice roller and he actually looked up the Chinese symbols for the die, and it was just so cool. I mean, there was just so many variations. And if I had tried to impose some sort of test exercise framework on top of the whole thing, it would have completely squelched the creativity of everybody in the room. And learning is supposed to be fun and loud and collaborative. So I know I'm like on my high horse here, but this is a real big thing with me. It means that I'm going to make crazy mistakes, that I'm going to struggle because I'm not going to remember something. And you can laugh at me and say, oh, maybe you know it because you just barely did it, even though I've been doing it for a long time. So that doesn't make you better or worse. It just means that we're learning. We got things in our memory available at a given time. Okay. And then one of the things I talked about this last week, but I'm going to talk about it again. So these projects are designed to be done within an hour or less, these mini projects. Okay. And they do kind of increment on each other. I should probably change these all to ones. Let's do that. Let's change this to a one dot. Is that going to work? I don't think it did it. Well, what did I do wrong? Let's try this. Oh, whoopsie. Change to, yeah, that should do it. All right. So there, let's make these, numbered. So, you just learned if they've been doing it for 4 years. Yes. Yeah. Yeah. So, and I people, I mean, you have to go through it over again. You have to constantly go through it. You can't, learning and knowledge is fluid. If you don't keep it fresh, it will go away even within a year, depending on what kind of brain you have. So anyway, here, these projects are designed to be under an hour. And most of these projects, I would say 3/4 of these projects I've already done in Python when I was at SKILSTAK. So some of them are really old, like the waffles, bridge keeper, roll, genpl, nyan, whatever, term colors, high agree. These are all args. 8ball is my absolute most famous project. Everybody loves 8ball, no matter how old they are. So there's something about anthropomorphizing code that just makes everybody really get into it. And we'll be doing all these. These are all tiny. So I don't know how many of these we're going to get done today. We'll probably get the first 3 or 4 done. And then I put some other new stuff that I want to kind of challenge. I put some filters in here that we could turn into bonsai commands. I put a Pomodoro timer, which is going to help us use state and save files. I put the interactive story game. This is a tough one. I put start an interactive story game here because every time we start the story game, I lose everybody. Because they get so into writing. In fact, we had one guy make a deal with his creative writing instructor in high school to do an interactive story game instead of a creative writing project. And they just fell off the map. So as soon as I do this is what I'm going to say, start an interactive story game. And this is a really good one because there's a lot of wrong ways to do this. For example, doing it functionally, like in a Turing complete function calls a function sort of way, it will blow up. You'll have like stack recursion problems. It's really, really fun way to learn how to code. Zet is I don't know if we're going to be able to finish that in an hour, but I wanted to help you have a note-taking system. And then these other two that I've been playing around with lately, but I wanted to start doing some network communication with just plain old TCP/IP networking. And we haven't talked about networking at all, and this gives us an opportunity to talk about networking. We're not actually going to talk about a lot of the bigger technologies until we need them, which is kind of, again, unorthodox. Most of the time, people, I recommend strongly against using Obsidian for note-taking. My personal recommend, because it's proprietary, and if you write anything in it, you'll have to pay them forever, even though it's free. I strongly recommend against Obsidian. I have done extensive evaluation of it, and I cannot get behind it. The best way to take notes, and apparently we have to go through it again, is to put plain common markdown into a GitHub repo. That's it. That's your best possible notes. Okay. So encrypt, decrypt files with public key crypto. I would like to explore doing a TCP peer-to-peer chat. Both the crypt and the chat can be used as bonsai commands and put into your monolith and used as hacker tools if you want to use them. If you want to pretend like you're a spy or a hacker or something like that, we can create two-way peer-to-peer encrypted communication. And that actually is not that hard in Go. So because it comes with all the encryption built in, you could not do this in Python or JavaScript easily. But in Go, it's like not a problem at all. So I added them because I thought that'd be, in fact, I'm kind of excited if you can't tell. I'm kind of excited to do these two projects because, no, Obsidian is not open source. No, it's not. No, it's not. It has a proprietary internal format that it says it's free. You have to go read deeper. You'll find out. They're both, it's not. It's not. They lock you into a proprietary format that you have to use Obsidian for. So maybe even if the code is open source, and a lot of people don't know that. And I didn't know that. I went into it thinking, oh my God, this is awesome. All right, so back, I gotta stop looking at chat because it's gonna. Now there are a number of projects that we used to do that I have now realized we can't do unless we have web dev first. So we will come back to these Go projects after we learn probably 3 or 4 weeks of web dev. And when I say web dev, I mean absolute minimal web dev, right? I mean, you can't do anything in the world today without knowing HTML, CSS, and JavaScript. You need to know them at a basic level, and that's all we're going to do. Vanilla JavaScript in order to manipulate the documents, enough syntax. So we will be doing web dev, and then we'll come back to Go after that. Normally, I was going to put the web dev either before all the Go, or I would do the web dev as a part of a separate course or something like that, or we do it at the end just to put a profile up on the internet. So that's gonna be that. The way this is going, we're gonna be. I mean, there's no way we're gonna get it done in 16 weeks. We're gonna be probably headed into Christmas before we finish everything, but we're covering a lot of stuff. We've covered the entire Linux command line, Vim, tmux, links searching in the command line, learning processes, Go programming, minimal web dev, and if you add up the number of hours, then I think we're doing fine. Okay, so again, and it's all free, so go through it as slowly as you want to. All right, so let's get into the first steps here. I would open it to questions, but if anybody has a question, you can go ahead and ask me. Or I just want to make a plug for it again. If you take a look at the schedule, here I'll put it in the chat. You can do bang cal or whatever, and then do rub schedule, and you can see the schedule. And then you can change week view is much better actually. So I just want to plug this. So we have co-learning happening every day from 4 to 6:30. Mostly me building my lab out over here for Kubernetes stuff. And then we have questions, conversations, and advice every day from 6:30 to 7:30. This is going to become a podcast that's suitable for work. And if you have Boost questions, you can ask them there. I was going to have another Q&A after after the SKILSTAK Beginner Boost, or pause for questions during the boost. And we will allow for questions to some degree. I'll try to do like 40, 50 minute segments, take 5 minutes, and then kind of go like that. But yeah, and then we'll go like that. Okay, so there you go. We have the tech learning stuff. So what I'm trying to say is that there's places for you to ask questions, and have the questions answered. If you want to go to the Discord, you can go there, of course, and get help. It's really up to you, and I don't try to tell you what to do, because everybody is different. We all learn in different ways. Some people want to learn on their own by grinding, and reading, and others want to talk to somebody. So it's up to you to make that decision. All right, so let's get into it. I think the first topic should be how to save your code, and so we're gonna do that now. I debated at this point whether to teach you the GitHub command line tool, the GH tool, and we will not be using that. We're only going to use Git. Okay, so what are we doing? We're doing the beginner boost. All right, so I'm going to ask the chat to help me out here a little bit, because we get repeat questions, which is cool. All right, so the first thing, if this is look, we are on week 16 of the beginner boost. So if you haven't seen the rest of the boost, you're going to be left hanging, right? So if you have questions, you might have to go back and find them and look at the beginner boost page. Me lab go. We're going to talk about that right now. All right, so here's the boost link. So let's first cover getting, let's see, did I put absolute minimum required Git skills? Okay, let's do that. So first of all, if you haven't got a tmux window open, you should have a tmux window open. So take some time right now to start up your VM, to SSH into your VM, and however you want to get onto the Linux command line. This stuff you should already have done. So, but I'm just telling you, there's a reminder. And then once you get on, so actually let me do that. I'm going to do all of those steps right now with you, because I hate telling people what to do. I like showing them. So I'm going to go all the way out. All right. I'm going to go all the way out, and here I am. In fact, I'm even going to turn off my terminal, and I'm going to turn my VM off. Okay. So in the tmux cheat sheet, the problem with the tmux cheat sheet is it does not follow the proper memory models for everything. Do not use the tmux cheat sheet unless you've watched my tmux configuration video last week. If you do, I take no responsibility for you screwing up your muscle memory forever. That is the only thing I'm going to say about that. I spent 4 hours talking about tmux configuration and how to properly use it so that you'll be compatible with Screen and everything else out there. And if you choose to not watch that and just use the cheat sheet, that's on you. All right. So that's all I'm going to say about that. All right, so let's go ahead and power down this virtual machine. I'm going to start up a virtual machine from scratch. I'm doing a number of these steps over again because, again, this playlist is going to be separate from the boost in addition to being down there. So, I mean, there's nothing wrong with the cheat sheet as long as you understand the muscle memory necessary from screen. Okay, that's why I covered it in that order. Okay, but it is a nice resource if you know that stuff. All right, so let's go ahead and shut down. I gotta shut down my VM. Pretend like you didn't see this part. All right, power off VM. All right, so I'm doing these steps over again for the people who are just joining us. You run screen in this house. You can do screen. That's what last week we talked about that. If you want to stick with just screen, stay with screen. But and if you're going to use tmux, I strongly suggest that you do screen plus, you do screenified tmux so that you can be useful on any system that has both. You bind control ASN prefix, but that's not the only thing. There's a number of other things. We covered that last week, so please go back and watch that. All right, so to anybody who already knows, who's already seen me doing this, I'm only redoing this because we have a lot of newbies in the thing that have not watched the beginner boost sessions up to now. We love you, we welcome you, but I'm going to repeat this stuff for you. So we have spent the last 2 months, the last 15 weeks, configuring a suitable production enterprise Linux environment in a Ubuntu server that we can then log into from our Windows or Mac machines or Linux, whatever, and start doing our stuff and be able to save it. All right. So I'm going to repeat the steps. So the first step is download VMware Player. If you want to buy Workstation, which I suggest you do, go for it. But for this boost, you only need Player because you only need to be able to run one VM. Step 2, download Ubuntu Server off the internet. I'm not going to go get it for you, but download Ubuntu Server, the Ubuntu Server virtual machine image, VMware image. Download that and play it. Otherwise, you can go out to the virtual machine. And if you want to configure your own, that's fine. If you want to use the one that we use, don't use Proxmox. Proxmox is broken unless, look, if you have a VM, that's fine. It's however you want to get to the terminal. I've had very strong feelings about Proxmox, having had it just totally drop me on my face this last week because it couldn't support more than 14 cluster nodes. But y'all haven't been here for that, so we won't talk about that. I'm not going to look at chat anymore. All right, so if you want to do this, you go to VMware Player. So you know how to get VMware Player, right? And then you do it. But what I wanted to show you is that if you go to github.com/rvxrob/boostvm, there's a link here about how you can run the virtual machine that I'm using. I prefer eventually that you learn how to make your own VM and set it up and configure it, and we do all of that in the boost. But if you just want the exact same virtual environment that I am using right now, then you can download the OVA file and double click it after you've installed VMware Player, and you'll get this. So you'll get something that will look like this not this one right. I'll go right here. View, no, where are you? Home. Okay, here we go. So create a new open a virtual machine. So we're gonna go open Anton, and I'm looking for the OVA file. I actually have already expounded it, but I mean, you'll just click it and you'll get it. I actually wrote a script for that part, so I'm gonna just run my little script here, and I'll show you what's in it. I have Git Bash installed and Microsoft Windows Terminal Preview. So again, I'm really briefly, so I should probably turn Steam off. I'm really briefly going through this stuff. Because, people, make sure you get Terminal Preview and not just Terminal. So here, this is MS, Microsoft Windows Terminal Preview, running Git Bash with a Groovebox dark theme that I've made, which is all in my .dot files, and a bash RC that works here as well. And then I've made a command called VM run. Oops, is it right here? Oh, where are you? I think it's an alias. Yeah, it is. So I wrote a function that, this is Windows, that runs VMware Workstation. It runs it, and it starts up a headless GUI depending on the name. So you can do this just by clicking on the OVA file, okay? And then it'll be there in VMware after that all the time. But I wrote this just so I could write it. I could run it from the command line without having to think about it. So, and then I can just keep trying to SSH into Anton. We covered SSH already. We're not going to cover that again. So, and then now I'm SSH'd into a virtual machine that's running on my machine, my Windows machine, just like a server, and I can be on there. Thank you for the follow. So now we're there. Okay. And you got, you know, all of my internal stuff. And so this is, you know, this is where we can start to run our stuff. And pretend like none of that other stuff is there. So let's get into how to organize your directories for Git. And then we started this a while back and I kind of dropped it off. So we're going to repeat this. So the first thing you need to do, and let me ask, this is kind of a review. How do you make a directory? First thing I suggest is that you make a repos directory, and I use all caps. I use initial cap repos just because I don't know why I changed that. Yep. So make dir repos, right? So you can make dir repos there, and you go into repos. Now, can anybody think of a reason why I would want all of my GitHub repo, my Git, not just GitHub, Git repos organized in a specific way? The reason is so that when I write scripts, I can assume from the URL to the Git repo this same organization in my home directory. This is something that noobs and veterans alike don't do, right? So yeah, so you can set repos, and then you get the repos. You can change it to be whatever you want. But the thing that's important here is that you make sure that, and we covered this in the Git config, but is that I have created a directory by hand called github.com. I have one called gitlab.com, and for a while I had SourceHut and other ones, and I put those as top level. So that's just like it was a URL, right? And then there's my stuff in rwxrob, right? And so now I have like all these repos in here. You don't need to mess with those, and you can see that the challenges repo is in here, right? And what I want to demonstrate is that when you follow this consistent directory structure that matches the Git repo, the Git locations, that you can do some pretty amazing things. So let me just give you one example of that before we get too far into the Git stuff. Let's say that I wanted to clone anything. Let's say what's something I haven't cloned. Neo. Let's go see if we can find Neo. Is Neo already there? So Neo is a program that's like the Matrix, right? NeoVim. No, we're not gonna talk about that. We could do NeoFetch. There's another one. Let's do NeoFetch. Yeah, let's do NeoFetch. All right, so let's do NeoFetch. So I can copy this, right? Not the link address, but I can just copy. Oops. I just want to copy the cloning name. Copy this. Right? Now watch. I can type clone, and then I can paste that. And because I followed a consistent directory structure, I am now able to, you're gonna have to go look at the title and stuff. We're doing Go programming, get ready, and then we're gonna go. All right, so I want you to see this, what it did. So this clone thing that I just did, actually, clone is what clone did is it went out, got the repo, determined the URL from the argument, and then switched into it, cloned the whole thing, and then switched into it. Now, I could not have done that if I hadn't made it a consistent structure. And I see people do this all the time. I see people put all of their repos in some like common repos directory without any directory organization. And then what happens if look, how many people have a .files repo? right? That's gonna, your dot files might be there, but then you're gonna want to go look at somebody else's dot files, and now you can't because you're gonna have to create an organization. So just trust me on this. Put in this particular thing, I'm going to ask you to trust me. Put your stuff in the same organization that is available on the internet, and you will be a much happier person. Let's say, yeah, if you're in the random repos gang, then don't talk to me, and please don't make any recommendations in my chat for the rest of the day, because if you're doing that, you have no clue. I see people do this all the time, and then they like, okay, how are you going to migrate from GitLab to GitHub, for example? You can't do it. You can't do it if you've got them all in one random directory. It's really stupid to do that. I won't say stupid. It's inefficient. It's dangerous, and a number of other problems. So just don't do it. Organize your stuff. I mean, you're going to have thousands of repos in here at some point. You're going to be looking at repos. I mean, I can clone any repo on GitHub in like a second and go look at the code myself just with one command. I don't have to go out to the web or anything. I can go straight to the repo. Why? Because I've organized my repos properly. So, you know, and believe me, there was one time I didn't do it right. I was random repos gang also, and I was blowing away my stuff. I'm like, I don't want to do that anymore. We're not going to talk about GitLab. If you want to see that, I have a great video on that. Hey, Izzy. So if you want to see my back and forth on GitLab and GitHub, which has been really frequent over the last 3 years, I can give you the notice on that. But ultimately, I'm a GitHub person right now. Mostly because my priorities are connecting with the community, participating in other open source projects, and being discovered and helping other people be discovered by potential jobs and employers, and they all go to GitHub. That's just undeniable. I mean, you can complain about Microsoft all you want and all that stuff. It doesn't matter. Those are the realities that we have to deal with right now. I have stuff on GitLab and over there. GitLab's interface is horrible. I hate it. So that's my short version on that. So you can adapt the stuff that I'm going to be telling you about GitHub and use it on GitLab if you want. But at this point, I strongly recommend you stay with GitHub, especially if you're a beginner, instead of going with GitLab. And there you have it. Okay, so NeoFetch, I just downloaded it, and I was able to get it really quick, and I can look at the file and read it all and all that jazz. All right, so that's all I was trying to show here. So now so after we connect it to Anton, we need to start up Discord, right? Well, we need to get someplace where, let's start up tmux inside of our current directory. I'm going to make a new window. So I have two windows. I'll go ahead and close this window. And I want you to do these things with me. I encourage you to, because if you try to say, I'm going to do tmux later, you're not going to learn it. So, you know, you can go to, yeah, it doesn't surprise me, but GitHub is not the model of technical architecture in the world. I say that all the time. I mean, Discord. If you're going to go to Discord for your technical direction, then you have problems. There are much bigger considerations than that. I love GitLab for CI/CD. That's probably the best thing that they do, but we're not going to have that debate right now. You're going to get timed out. We're in the middle of a video boost. You came in and you're talking about things that don't have anything to do with the current topic. So I'm going to ask you to chill a little bit. Okay. Thank you. You know, I love you. You know, I love you. I'm looking forward to the interview with you. And then you can kind of hit me with all that when we do our interview. Okay. That'll be fun. In case anybody doesn't know, Izzy is a big deal over at Discord. They actually work at Discord. They're a frequent participant in our QCA forums, and we're going to dedicate an entire QCA to working at Discord. I love Discord. I use it all the time. I'm not mad at Discord. I don't want to defend my position on whether you should go get technical architecture direction from Discord, which I think will be a fun debate. So stay tuned for that. All right. So back to what we're doing. So we're making GitHub repos right now. All right. And we're organizing our stuff. We just fired up a tmux repo. I mean, not a repo. We fired up a tmux session, and based on this, why do we have a tmux session open? Because I might want to do some reading, you know, over here, right? Let's say, you know, how to create a Git repo, right? And then I want to be able to go back over here. So I'm doing Control AA, right? How to create a brand new repo again. Okay, let's go read this, right? So I can read this, and because I can see its links, I can maybe read it over here, and then I can go back to my other one and actually do it. And if I want them on the same window, I could do that. I could split the pane, but I don't have enough space because I have a big old font for y'all to read. So I'm not going to do it that way. So I'll go ahead and just do that. And then we're going to go over here, and we're going to try to make us a new repo. So back to where we were. So we're going to go into repos, and then we're going to make a directory called GitHub. I already have one, but let's pretend I didn't. So github.com, right? And then we're going to cd into that. And then we're going to make a repo in here that matches your username. Now, if you don't have a username, you should already have a GitHub username. But if you don't, just take a moment to go over to GitHub and create an account. All right. So it would look something like this. Let's go incognito. Whoopsie. Then it won't know that I'm logged in. Incognito has lots of good uses that don't involve the regular uses, just in case you're wondering. So here you go. This is what GitHub looks. This is what GitHub looks like when you haven't ever been here before. Go ahead and sign up for an account. I suggest using lowercase usernames that are memorable and that you can type quickly and easily. If you have the good fortune of having a consistent username across all of your platforms, social media, I strongly encourage you to do that. I'm not going to get into that right now. We will get into that later, though, when we talk about employability and finding jobs and things like that and managing your brand and all that crap. So, think about it. But for you can always change your name later, but because you don't have a domain name or anything associated with it, but give it some thought. And then go ahead and make a name. If you haven't done this, we did this already at the beginning of the boost. So again, this is for the people who are coming in from Go who don't know that. All right. So we're going to go ahead and we're going to type, after we get this down, we're going to then make a repo. Okay. Now this is where things get interesting. Okay. So, there's no easy way to do this. What we're about to do is the absolute most common place that I lose beginners. Every single time, this is how I lose beginners. And we're going to add an SSH key to GitHub. All right. Now, it's not that bad, but when I have an absolute beginner, I usually lose them right here. All right. So the first thing you need to do is you need to create an SSH key. Now, you should have already done this with the boost because we are already SSHing into Anton, right? So you're going to run the command ssh-keygen, right? In fact, I'm going to put the command in my thing. ssh-keygen -t ed 25519. And you want to use ed 25519 certificates these days. We talked about SSH before. SSH is a way to log into things using public key cryptography. It means it creates a public and a private key. Never, ever, ever, ever show anybody or stream your private key, but your public key you can give to anybody. In fact, Ubuntu server will go out to GitHub, get your public keys, and make it so you can log in without a password. That's how good it is. So go ahead and go through this process. And in fact, let me go through it in a container just to show you. Just disregard this for a second. Let's do Ubuntu. I don't know if I want to do it here or on one of my other servers. Yeah, there's a lot of things I could do here. I have like 40 machines to go to now. So let's go on my Mac Mini over here, and we'll try it over here. So let's make a new account. So sudo sudo add user boost. What's my password? I don't remember. I think that's it. Okay, so there we go. A new password. It's not an admin user, so don't worry. Yes. We don't need any of that. So I'm just adding a user so I can show you how to do the SSH stuff. Sudo, you should know this stuff because we've been doing it. Sudo su dash boost. All right, so here we go. We've got a brand spanking new account that has no bash into it or anything, and I can do ssh-keygen. This is the command you need to do. -t ed 25519, and it asks you where you want to save the key, and if you don't have one already, say yes. That's kind of standard. Now, for the GitHub stuff, I would not necessarily. I'm gonna let you make a decision here. If you use the passphrase, you have to type it every time, unless you set up some sort of SSH agent, which is a little bit more complicated than I would encourage a beginner to do. So for this exercise, you can just put enter on the passphrase, and you'll get a nice happy fingerprint. And then you can, now this is not anything I'm going to use, so I can show you what we're going to get. So when you do this, you get ls-al, you get a directory that's called .ssh. This, like, what does this have to do? Go, right? Well, you have to do this in order to get a Git repo. So we're going to go into ssh. We did this already in the boost. We're going to do it again. cd.ssh, and you see all your configuration files in here if you want them. But more importantly, you see a public key and a private key. Now, let me tell you again, I am on a sample account that I am not going to be setting up anything for GitHub. So you can go ahead and look at what one would look like. But you can look at the private key, just never, ever do what I'm doing right now on a live stream. Because anybody sees this private key, they have 100% access to everything you've ever done. So with that key, super duper stupid, and people do it all the time. So I'm going to be stupid for you so that you don't ever do it. This is your private key. As you can see, it's very small because it's ED25519 instead of RSA or some behemoth alternative, or completely insecure like any of the other ones. So that's what you should be using. You're in? Nice. Okay, now here's another one. So we have this one, ED259. This is .pub. So this is your one-line pub key, okay? Now, this is what you're going to be copying and pasting, okay? You're going to copy and paste this into, when you go over to your GitHub, all right? You'll click on your settings, and I'm not going to show mine, obviously. But if you go to settings over here, and you'll see some stuff here. None of this is secret. But this is, and you're going to click on SSH and GPG keys. To tell you the truth, GitHub is pretty damn good about not showing secret information on the screen at all. I can click on this and show you my keys. I'd rather not show you how many keys I have set up, though. So that's something I don't want to show. But if you go on there, and then it'll say add SSH key, and you can put an SSH key in there. We are not going to do GPG keys for validated commits today. We'll do that at the end, because learning GPG is yet another thing to get into. We don't need it, right? We don't need it. We just need an SSH key in your GitHub saved. And when you have that, by the way, then you'll be able to do this to test it. Okay, so once it's there, the way to test that your GitHub account works is you do ssh git at github.com. And if it works, you'll get this. It'll say, RWX Rob, yay, you've authenticated, you're all good to go. And then it closes the connection, because it obviously isn't going to allow an SSH. Now, this seems really weird because your name's not in here at all, right? But the reason for that is because it is using your public and private key that you just set up, okay? And you can go ahead and make that connection. And once you have that connection made, now you can start to communicate with GitHub using Git. And as I said, we're not going to go into the deep dive on Git. We're just going to do the minimum. All right. So now that you have decided what your username is, you can make a directory for your username that matches, right? That can't be really done automatically. So go ahead and make one. I got mine already made. Multiple keys register for multiple accounts. Yes. To upload. Well, yeah. Most of these people won't have that. But yeah. So yeah, you can actually have lots and lots of keys there. Over time, you'll get that. Every time you want to add access to GitHub or to any Git repo, you have to add those keys. But that's all a part of understanding SSH, which I debate about how much of that to go into on a boost. We definitely are going to go into all of that when we do home lab init, which is a different playlist about how to set up your home lab. And I think that's where we'll do all of that stuff. I have another series of videos called Home Lab and It, where I'm setting up my own home lab and I'm showing people how they can set up their own home labs, and that stuff is kind of like, you know, Boost 201, right? It's kind of like the next thing you'd want to do. But first you have to get good with Git. So we're going to go back into RDX Rub. Now you're not going to see anything here. You should not see anything here. You might have a notes directory or something like that. And that's all good. Now for beginners, again, the steps I'm now going to give you are almost always somebody in the crowd gives me crap about it. The steps I'm about to do are designed for absolute beginners who've only started using Linux maybe 4 weeks ago, who don't want more steps than necessary. All right, everybody okay with that? So we are not. If you know what's up with Git, we're not going to do Git init and any of that crap. We're not going to do any of that. So pretend like we don't know about that. We're going to go to GitHub. Okay, and we're gonna go to our GitHub account that we just set up. You know, we're all logged in and we haven't done anything with the profile yet, but and we're gonna click on the plus over here, and we're gonna make a new repository. And we're using the graphic interface here, and it says new repository. And let's call it code. You could call it Boost Codebook. You could call it. I'll call mine. Boost Codebook. Actually, I could just call it Codebook for the sake of this boost, and I'll delete it later. Oh, I already have one. Whoopsie. Boost Codebook. Call it whatever you want. Remember, you're going to be typing it a lot, though. So, or tab completing it, whatever way. So, and then I'm going to make mine private. As I said, this is going to be where all your nodes and stuff are going to be. We're going to be putting our code in there. Some people you might want to call it lab. I have a thing I use called lab. I put everything in there, all of my experimentation on every single thing. It's just, but Codebook is what I've been, the term that I've been, you could call it Go Codebook if you wanted to. I mean, it's whatever you want, right? I don't know. Should we call it Boost Lab? I kind of like lab. Why don't we do that instead? It's my Boost Lab. Right. So the idea is that you have a place to go tinker and to save your results and be able to find them again and in sort of a non-organized way. Now it's hard because you usually want to combine this with something like a Zettelkasten, which is like a lot of notes, right? But in this particular case, you're going to be writing code. If you wanted to do Go Codebook, you could do that. You can organize it however you wanted to. I'm going to go ahead and make a thing called Boost Lab, and I'm going to proceed with the idea that we're going to use this for all of our experimentation and learning. And it's going to be a mono repo that's going to have, you know, mono repo full of learning experimentation from SKILSTAK Beginner Boost. But I mean, if you call yours lab, eventually you could just use it for that. Private, I don't need a README file. If you click on README file, it'll make one for you. You really don't need one. You don't need licenses or any of this stuff. Because why? Because it's private. It's just a place to take notes, right? And then you click create repository. Okay, so, and this is where I lose beginners. Beginners see this and they freeze because they're like, oh my God, it's so complicated. I don't want to do all that. You don't need to do any of that. You don't need to do any of that. Okay? Just calm down and go back to your terminal and I'll show you how to get around this. All right? So PWD to show where I'm at, right? So I'm github.com/rwxrob. And the goal here is I want to get that brand new empty repo I just made on GitHub onto my computer so I can use it. And we already checked to make sure our SSH works, right? So now we can just clone it. And so this is the clone command. And I'm going to, I'm trying to decide where we need to go with this. We need to go boost. I'm trying to take notes as I go so that y'all have something to read. So let's say I covered, we did ssh-keygen -t ed 25519. All right, we'll come back to that, and then this one, we covered creating GitHub repo account and first repo. Okay, did I spell GitHub right? And then we did git clone git at github.com /u, right, /boostlab. And you should probably put .git in the end. I learned that can bite you when you're doing configurations on things. So you definitely want to keep that keygen typo. Oh, thank you, Kat. All right, so I mean, maybe you have a note-taking method already that you've been using, but if you don't, this is also where you can take your notes, right? So that's why I'm kind of going through it. Strictly speaking, I'm kind of doing a different class. When I was at SKILSTAK, we used to call it fundamentals, and we pretty much just ended fundamentals, like, except for getting this GitHub stuff, right? That was the end of fundamentals. And then there was another course or another, it wasn't a class. It was just an offering that I had called, Go Programming. And that's what we're doing right now, but we assumed that all the other stuff was there. All right. So we don't need to do any of this stuff. You can read that if you want. And all right, so now we're in here. How do we do this? So git clone. First of all, you have to have git, right? So sudo apt, you should have it if you're using the Boost VM. If you don't have it, you need to have it. So sudo apt install -y git, and you should have it, right? Fun fact: one of the reasons that we put git bash on Windows is because you get git automatically with that. You can actually use it to synchronize across your Windows host machine. And here, so like if you say for example you want to download something off the internet, put it in your Git repo, you could download it off the internet and put it in your Git repo and git push it, and it would actually go and you have to git pull it down. So the idea of Git is that you're pushing and pulling data from another source, right? It's not that complicated. That part of it's not that complicated. So then we're going to do git app, and we already did that. We're not going to do it now, so I already have it. So then they do git clone, and then the format is git at, you'll probably have to look this up for a bit, git at github.com, :. All right. Now you're going to read a bunch of stuff that's going to tell you to use HTTPS. Don't use it. The only time you should ever be starting something with H, in my opinion, is say you're on site at a business like I do at work, and I want to be sure that the thing I clone, I don't have any write access to it. So I do HTTP clones all the time. And what these do is they just create a copy of it. It's like copying down the repo so you can read it, but you have no intention of changing it or pushing anything up to it. And I really like that, because at work, committing to a public Git repo internally from a work system is a huge legal no-no. People do it all the time, but unless you've gotten approval to do that, that's the kind of thing that, depending on the corporation, could get you fired. So just a little tip here, even for some of those people who might already use Git, I actually use HTTP URLs on occasion, because they're just copies of, it's just like SCP. You're just like copying down the thing, but that's not what we want, right? We want to be able to have full access to it and push and pull and all that. So we're going to do git at github.com : people will put a slash there all the time. That's a huge, gotcha. And then we put the name of your account, and then slash, and then the name of the brand new empty repo you just made, right? Now that will come on in. It says, "Oh no, you appear to have cloned an empty directory," and you should not be worried. It's like warning, right? It's like, you know what you're doing. So then you go into the empty directory, right? You're going to go into boostlab. It's all stuff you should know by now. I cleared my screen. So there's nothing here. I mean, there's really nothing here. Oh, wait, what? what's this? Okay, so let's talk about GitLab organization, GitHub organization, repo organization just a bit. As you can see, I am now in github.com rdxrub boostlab, and I've got this .git repo, and that's the only thing, right? This is considered an empty repo. Now, you know, if we will someday, if you want to, you can get down and dirty inside of here and go look at everything that's going on there. In fact, if you do over-the-wire bandit, it has some hacking that you can do by knowing how the .git repo is organized. But all you need to know is the way you identify a Git repo and distinguish it from everything else is it has a .git repo. If you have, and this is kind of an interesting tip, if you have a bunch of code that you got from a Git repo and you want it to stop being a Git repo, you just delete or move that .git repo out of there to someplace else, and the whole thing will just become standalone. That's a very dangerous thing. You normally won't want to do that, but you can do it. I do it all the time. So, because sometimes you want the code, but you don't want it to be a Git repo anymore, right? So just know that that's in there. And another thing that's kind of cool, which I don't know if I want to recommend, you can actually move the .git repo out of there into the temp folder temporarily, mess with all your files, and then bring it back. I'm getting ahead of myself though. These are all Git tricks that they're really things that I really don't want to talk to beginners about. I don't know why I'm doing it. All right. So I just want to show you it's there though, right? It's not empty. There's something in there, but it said, do you want to create a README file? And we're like, no, I want to create my own README file. Now, if you clicked on yes, you would have had a file there and it would have appeared and it would have downloaded, but we didn't. So we're going to make one. Now, how do we make a file, right? Well, we can just do readme.md and then edit the file. And I did that because I want it, as a habit, to make sure I can edit. You could probably just do vim right away and do it. And we could just say beginner boost learning lab notes, etc. I mean, whatever, right? And we already went through Markdown. If you need to go see the Markdown cheat sheet, I already have that. You can go look at that. Oh, do I not have it? Dang it. Well, this one is still the same. rdx.gg lang md. And go click on the simplified one. And anyway, so now we have something to save, right? So here's the other commands for Git, the minimum necessary, right? So do git add, okay? Now, this is where I usually take tons of crap from people. Okay, I have such a hard time doing this, knowing what I know now about Git and how bad the habits I'm instilling in people. But if we take the time to learn Git properly right now, we'll never get to go. All right, so this command adds everything recursively in dir incur dir to Git. All right. Is somebody going to yell at me now? I know there's at least one. I know you want to. I know you want to. I said it already a million times. I am not teaching you bad habits here. I'm teaching you the minimum to get the stuff so it's saved. And then when you want to go back and layer in actual proper Git knowledge, you can come back in and layer that on. All right. I don't like doing this. All right. So what this does is it adds, if you wanted to, you could just add readme, right? It would only add the one file. But if you just want to memorize one command for right now that will always add anything you've changed, then git add -a dot. That will, if you do it at the top level directory, that will always add any change you've made to Git so that you can push it. All right. And then the next command is git. You probably want to do git status, show state of files in Git. And this is another one of those rabbit holes that we could go down. If I do git status, I mean, like, you may like, well, what's cached and unstaged and all this stuff. Please don't worry about that right now. I want to get onto the Go coding, right? So this shows that you're on a branch main, okay? and changes to be committed, new file readme.md. So you have a file that's been added but not committed. So the next step is to commit. Now, if you're using VS Code, you can do this with like 1 or 2 button clicks. And I used to do that, but at least this way you're learning some Git, right? So git commit. Now, for right now, again, I'm going to get crap on this. Compose a commit message and commit. Just start somewhere. I know, because I know it's like so easy. So here we go. So now we do this. We do git commit. Now you can do -m and all that stuff and pass a message if you know what you're doing. But if you don't know what you're doing, trust me, just do git commit. And the reason beginners want to use git commit is because of this. Add an initial readme.md file and do a bunch of other stuff. This is why I'm suggesting as a beginner you do this. Okay? When you're writing a commit message, and this is, by the way, why you learn VI, you remember back when I was making all the justification? Now, you can map this. You can map this to Emacs or Nano or whatever. This is a good example of why we learned VI and so long ago, because this is the standard thing that comes with it. It's built in. But see how the colors are different here? This is because you only get 50 characters that before stuff will start to truncate when it's being listed. So if you're a beginner, this is a good reminder to like keep your messages under 50 characters. And how should you organize your messages? There is a huge, long blog that everybody reads about this, but I'm going to tell you the simple thing to remember. Answer the question, if I commit this, if I add this change, it will, all right? So you can say add or commit. That is what you should say. And then you should say no punctuation, no period. I don't know why, but that's been the standard. You see? So, and also initial cap. I don't know why it's not actual English, but this is the standard way to do this. I cannot tell you how many people who do crappy commit messages. That spell checks. That's automatic. That's built in, my friend. Yeah, that's built into Vim. You don't need a plugin for that. It should be set automatically. So, but as you can see, Vim is showing this that I'm overboard here, right? So I can delete that off. Spend time to write good commit messages. Yes. The commit messages, even if the commit message is longer than the change, trust me, you'll do it. Also, don't say added. Keep it in present tense. Hide everything after the first line. Yeah, and that's why this first line is so important. If you want to put a bunch of details down here, fine. I never do, because I try to keep my commits, small enough that I can capture them in 1 or 2 lines. A lot of times the commit messages will get squunched out, but not always. So again, the best way to do this right from the beginning is to just say, if I add a commit, this change will blah. Now, there's going to be some coders out there. There's going to be some wonderful lazy programmers out there, and I'm lazy as a compliment, who are going to try to automate all of these steps. And I've done it, right? Yeah, and I've done it. I automated all these steps, and I made a command called save. I'm very ashamed to say. I probably still have it somewhere. Do I? Yeah, here it is. If you do this, and this is back when I was using GitLab, we did bash programming already. Can you tell me what it does? Right? I no longer encourage people to do this. So because of just for no other reason than the commit message, right? And I mean, this is a pretty intelligent little thing. It goes and checks to see if it's in a repo, and it does all of this, you know, pushes for you. But I got to tell you, you don't need it, right? You don't just stick with the commands. Not only that, because you're beginning, right? If you're just starting out and you start to already script away all of the stuff that you need to learn. This is why I don't use, for example, in Kubernetes, everyone asks me, why aren't you using K9S, which is really great. It's this great, you know, command line tool for doing Kubernetes. And the reason I'm doing it is because I haven't even learned all the kubectl commands yet. Eventually you will get that. And by the way, even when you do get that, you have to be careful, because the more stuff that you obfuscate away, the more you make it impossible for you to be productive later when you're on a system that doesn't have your blessed tools that you've been working on. So, you know, it's that same idea. So at some point you want to get good with just the regular things. Sometimes, you know, things you do all the time, you might want to do it. Anyway, so add a good commit message. Did you see how I had a trailing space and it told me I have a trailing space? That's a kind of a nice little thing. We went through that in Vim configuration 2 weeks ago. So I showed you how to add that if you want that. And then we just save it, right? And when you save it, it's like, oh, okay, it committed. Yay, my stuff is saved. No, it's not. Your stuff is committed locally to the computer locally, and that's really good, because now you can like go back to it if you like screw something up or you delete a file on accident, and believe me, you will. You absolutely will. But you can, but it's not committed to be saved up in the cloud yet. So the extra step, and since this is private, you can pretty much do this every time. You don't have to wait, right? So then we're gonna do this. We're gonna git push, and git push is gonna push up that change. And what it did is it sent the change up to the site, and this big empty page that we were on before, we can now refresh it, and we get our thing here. Now, you may remember from the beginning of the boost, we didn't talk about any of the command line stuff. Back then, I said if you want to take notes, you can just click on the little, you can click on the, you can just take notes right here, right? Oh boy. That would be really great if you did. I would love it if you did that. No, but so here we go. We've got, you know, all these things like, so we could say, we're getting with slab notes, Golang, Go programming or whatever, right? And I can just click on, if I want to save it up here, here's the update readme. This is the same message. And then you can add a description if you want. And you can go ahead and commit it to the main branch, which is normally frowned upon, but not for this case, we're fine. So we're going to click save. And now I have Go programming in there, right? So but just remember this, if you change your stuff using the web interface, which is totally acceptable, that you're not going to get it here until you pull it. So we just made a change from the web interface, but it's not here. Now, what happens if I change it here? Anybody ever done that? If I start to change this, and then I'm like, oh crap, that's right, I made a change up on the web, right? Then you get what's called a merge conflict, and they suck. You never want to do that, because you have to. I mean, they're not that bad. You can get around it, but the best way is to just avoid merge conflicts, and then what you do is you do git pull. And if you do a git pull, that will grab all your changes. And now when you look at README, you can see it's there, right? And you can do git history if you want. That'll show you, what is it, git show? Yeah, there we go. So git show will give you all of your changes. And you get status, you see, git status shows you that it's been changed, but git show will show you all your history. Yes, if you don't understand, please go ahead and ask. All right, so here we have, so as you see, I made a change here. If I make another change here, so it's like we could put something like, I don't know, fun fact, Golang is the tag to use when searching for information about Go. About Go. And go back, I mean, this is all in the markdown stuff we already covered. About Go, there. And we can save that, right? So now, if you've already saved the file, you can save some time by combining the commit message and the the push message if you want to. So we could do this. We could do git commit, right, readme -m. You could say added note about Golang. Oh, I should have put add note, right? Add note about Golang. Now, this is going to be, when you're taking notes, it's kind of annoying to have really, really a lot of commits in there, but I'm just doing this for the sake of, you don't need a git add. You can just do a git commit. If it's already been added, you can do a git commit and skip that step. So you can just do that, and then you go git status will show you that it's there, and then you just do git push. So if you know that the file has already been added, you can skip the add step for that file and just do a git commit. Okay, so git remote -v. That'll show you whether it's been there or not. And then we did our git push already. We'll overwrite the local file. No, it will never overwrite a file. That's what it's for. It's to protect you. It will never overwrite the file unless you do -- force. And you'll get what's called a merge conflict. And when you get a merge conflict, usually the easiest way to resolve that as a beginner. In fact, let me make a merge conflict really quick on purpose. Let's catch up here. So git commit. You can also do git push, right? And I also talked to you about git commit readme or file there already, right? -m add file, and you can just do that. So skip the git add. So push up to GitHub and git pull any changes to main to repo on GitHub. So we talked about that. Now let's do a merge conflict. Working directory, yeah. All right, so there's a ton of stuff to cover in Git. I mean, this is just the minimum, right? And then let's do a merge conflict. Okay, so let's say I'm like cruising along. We'll make a hello world here. So we say, func. I know about import main. No, we'll do package main. I mean, let's say we got this going on, right? And we just want to say, I mean, we're getting ahead of ourselves, but func main. Hello world. Okay, that's anyway. So let's say we'll commit this, yeah. So git commit -m. Actually, no, I gotta do the name of the file first. Then -m add hello debug world example. And it is nice because you can go back through your notes and see, right? And git push. And if we come up here, we'll see this is here, right? So let's say you change the notes. It's more likely that you're going to change something from the web interface because you're not going to have your terminal with you. That's a very common use case or a common scenario. So another reason for this would be if somebody else was contributing to the project from another place, or you had a laptop and you want to use Git there, and you want a desktop and you want to use Git there, right? The more places that you do development from, the more at risk of a merge commit you are. So let's do a merge commit. So let's notice that we say, oh, I was at school, I was on my iPad. No kidding. You can actually go on your iPad and take notes or whatever, if you can, or whatever. And you're like, you didn't have access to your terminal because you haven't set up SSH in the cloud or whatever. So you just want to go change your notes. you can go, you see just something simple even. And it's usually the simple stuff that will trip you up. Because you'll just go to make a typo fix. You're like, oh, it's just a small fix. And then you'll go back to do your coding and you'll have a merge commit. I'm like, oh, right. So you go here, you click on commit changes, and I changed it to go language programming, right? So I don't care about update. I will eventually. Yeah. People always tell me that. I know. I don't go to sites that I would get phished anyway. So, but yeah, anyway, I do need to do that. Thank you for the reminder. All right. So anyway, so there's no language programming here, right? I could put here the Go programming language. So this is a contrived example, but I've just made a merge conflict, right? So now let's go ahead and save that again. So I even have it in my history. Remember that whole thing with history? Did you see how I'm going through my history? How am I doing that, my friends? Set-ovi, right? I'm just pushing up. I'm pushing K to go up because it's just like VI. And I'm even gonna go search for debug. I'm gonna go look for that line that says debug on it. Whoops, is there one? Maybe not. There it is. So same exact commit. I can actually repeat this commit message and just change it a little bit. I can go add. I could say. I don't know. Change. Go to the Go programming language. I mean, this is a really, right? So now watch. Git push. Oh, crap. I guarantee you're going to do this. So knowing how to get around it, there's lots and lots of ways to get around it. I'm going to show you the really lame, easy way. Somebody's going to yell at me in the YouTube comments or something. They're going to yell at me, but I'm going to tell you the easiest way. So I didn't. Normally I should have done a fetch first, right? Anytime you git push, how's it going at tennis? Anytime you git push, you should always do a git pull. Anytime you're going to do a git push, before you do the git push, you should do a git pull. All right. And you are definitely, we got a raid from Het. Thank you so much, Het. We're kind of in a merge conflict hell on purpose here. I'm trying to explain it. Everybody's been there. You will be there. There's many ways to resolve it. Suffice it to say, we're not going to do it the easy. We're not going to do it the proper way. We're going to do it the kind of sledgehammer way because it's easier for beginners to understand. Okay. So here's the thing. The problem with the merge conflict is that the two files are totally messed up now, right? And it doesn't know what to do. This says the updates were rejected. Sometimes it will try to merge them. This is usually caused by another repository pushing to the same ref. You may want to first integrate the remote changes, git pull before pushing again. Note about fast forwards and git push. This is like blah, 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 blah. What was that? And why did you delete it? Was that a question? Just a sec here. Ascertainment. You didn't need to do that. That's okay. Yeah, so that's fine. That was off topic. Yeah, it was off topic. I don't want them to feel like it was bad though. That's a question for the Discord. All right, so we're making a boost video right now, so we're trying to stay on topic. It's really hard. We're supposed to be Go coding. Okay, so now let's try this. Git pull. Git pull. And if you're lucky, oh my God. And if you look at this and you're a beginner, you're like, oh my God, what do I do with this? I have divergent branches. Oh no. What do I possibly do? Oh man, git config pull rebase false. You can replace git config with git config global to set the default. I don't want to do that. I don't know what to do. I don't know what to do. So if you're lucky, you need to choose a merge strategy. I know I haven't even chosen a merge strategy yet. And I actually don't want to choose a merge strategy because we're talking about beginners here, right? They even know how to configure their git. Now the first time they do a git push it's going to tell them they need to put their username and password in it. We didn't do that part. Dang it. We didn't do that part. I'm going to break this on purpose so I can fix some stuff again, so I can show again. We missed a part. We missed a part, and I feel bad. We missed the part where you have to add your username and password. I mean, your email address and your password. Git RMM. Git clean FD. Git cherry pick. There's so many different ways. Look, to all the advanced people who just came in here, before we did any of that stuff, I told everybody that I am trying to do the least difficult steps for an absolute beginner who's never done it before. Did it ask you for the global stuff? Okay. Well, I think you figured it out though, right? Zaz Gaming. It showed you that you just put your email and your username. All right. I think that I forgot to show you how to do that, but that's definitely something that you'll have to do. So creating your GitHub account, your first bootstrap repo. What was it? It's git config -- global user.name your GitHub username. And the other one is I think it's user email, right? Email. I think it's name, first mail, then name. Okay. Yeah. So you make sure to add those. Those are not hard to do. I just remember that those are going to store them in your .git configuration. Now, you can, for now, you don't care. You can just add it back again later. But eventually, when you manage your dot files, you're going to want to start keeping some of that stuff. Not all of it, because you got secrets in there. But you're going to want to put some of that stuff in a dot files repo that you can put on anything, so you don't have to keep doing it every time. Yeah. Set up your email, have GitHub generate alias for you. Don't use your sign up email. Yeah, I guess you could have GitHub use an alias. Yeah, I use my sign up email, but I can see reasons not to do that. If you don't want to hand over your email, but I don't care. Yeah, that's interesting, Foul Moves. Thank you for mentioning that. I forgot about that. If you want to be a contributor to GitHub and you don't want people to know who you are, I mean, they can find your IP unless you're going to do all your work from a VPN. That's to the hackers out there. Yeah, you don't have to give up your email if you don't want. I don't care. So we haven't mentioned git ignore yet. No, we're like, they haven't even done git push and git pull yet. I mean, we just barely did that. And I just talked about a merge conflict. All right. Now, rather than doing all this crazy stuff, the best way to get around a merge conflict is to delete your changes. I mean, watch this. Okay. So, I mean, you could do this. You could say, move readme to readme. Don't yell at me. This is for beginners. This is for beginners who don't know all the fancy other stuff. I don't want to teach it to them yet. And then you do git. You could do git pull now. Oh, we still have a problem because we already committed the other one. It didn't work enough, did it? Yeah, let's do git restore readme. Git restore is probably better. I'm glad you mentioned it. Yeah, but you can also move it and then commit it, which is not good. Now, when you do git restore like that, you just threw away all your changes, right? So that's the thing I want to make. So if you do git restore, no, it didn't. It didn't do it because it committed it. It didn't do it. No. I think I have to do my merge policy. I didn't think I was going to have to do that. Git pull then commit. It won't pull because there's no merge strategy. Yeah. 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 What do you think's the best for beginners? I'll tell you right now, my beginners never had merge conflicts because I put it all in a save script. and I made sure that they never made any changes from any other place. Git remove, git. You can do git co or restore. Git status. Git pull. See, it says git pull to merge a remote branch. I think we have to set merge stuff, and I hate that we have to do that. That's a new thing. They did not do that a few years ago. Yeah. I had a script, but we're not going to make a script for that. This is just absolute beginners. So the moral of the story is merge conflicts suck if you're a beginner. They really suck. They're really bad. So just get in the habit of only changing your stuff from one place if you can, or better yet, always just do a git pull before you do a git push. All right. Always do a git pull before you do a git push. And then we can do it that way. Okay, that's very cool. I like that you got those automatic. Thank you for that, FileMoves. That's really great. And so let's go ahead and do. You need to write that tip up for me, FileMoves. Yeah, I saw that. I want to see that tip because I want to start putting that in there. So I'm going to start. I'm not going to use it for anything I do, but there's a chance I might want to make another GitHub account at some point and have it be anonymous. So that's a really good tip. You might have to, well, I'll go back and look at the video. Anyway, so, I mean, that's an advanced thing. We're trying to help beginners here, and we're trying to get to Go code. How much time we got? We're going to get to, this is all, I promise you, Go programmers, future Go programmers, this stuff, if we don't do this, you're going to be very sad because you're going to end up losing your code. And you're going to be working hard on the code, and you're not going to have it. So I went ahead and put this into the beginning. It's always a problem, though. Git has continued to be a thorn in every developer's side for history. But you got to know it, man. You have to know Git. I don't think there is a more essential skill besides Bash Linux command line than Git to do anything these days. Use SVN. Yeah, I set up SVN and CVS for my CSV or CVS? CSV. CVS. Yeah. So I'm confused. Is my local copy still different? If you have a merge, okay, so if your local copy is different and you pull before you push and you have a merge policy that we're now having to fight with, that's good. It will put in those changes, but sometimes when you get the pull, it'll say, I'm sorry, I can't resolve the changes. And if it does that, then you can resolve the merge, or you can move the file out of the way, do the git pull, and then make the changes. You should be doing a git pull before you do any work at all. But the problem is if you got two people working on it all the time, there was a time, by the way, SVN and CVS, that people locked out other developers, so they couldn't make any commits. And then Git decided to say, we'll leave it up to the developers to make sure that they're working on the right things at the right place and then we'll help them manage merge conflicts. So yeah, the final, I don't know about that. I mean, if you're doing, yeah, you can, I wouldn't use naming personally. The one that recommends fast forward. Fast forward is the one I usually use. Yeah. Yeah, there's some really amazing stuff in Git. So we're going to set the fast forward policy to fast forward only. This is the one you didn't used to have to set this, so I'm not very good at it. But that should do a git pull, and that, nope. It says that you can't fast forward because the stuff that we change is in the same place. Squash the commits. Oh my gosh, yes. Merge the default strategy. Rebase equals false. They've changed it a lot, actually. Hey, yeah, thanks for the cheat sheet. Let's put that in the links. If you really want to get all that stuff in there, but you shouldn't have to. This is actually good for me because they've changed how to resolve merge conflicts, and I don't have merge conflicts anymore because I don't do that crap. I mean, not as much anyway. So I definitely want to find out how to help beginners go through. This is why we do a boost every year. They've changed this merge policy stuff this within the last year. So, you know, it's gonna be a year and a half. Yeah. And I mean, even the beginner, I mean, even the veterans like me, we like come in and use the thing that we've been using forever, and all of a sudden it doesn't work the same way because they changed something. It's like, so we can't fast forward that change. So I'm gonna move the README to temp. How about that? And I'm gonna git pull, and that should not have a problem. Why isn't it doing it? What do we have a problem? Deleted readme.md. For me, it says rejected master fetch first. Failed to push some refs to get a GitHub. I mean, fetch is a different step that I don't normally do ever by itself. Yeah, but if you're using GitHub desktop, then you're bypassing the use of the terminal completely, and that's not kind of consistent with what we're doing. Get Kraken. VS Code has buttons to click. I mean, there's a ton of ways to get around this, but none of them allow you to use the terminal. And that's why I think it's worth going through the extra pain to do this. First, they get suggestion. That's a cool one too. Let's put that one in there. Yeah, I want to get past this situation. I know how to brute force this, but I'm not sure I want to show beginners how to brute force it yet. You know, I don't know if I would. Master terminal, we must. Master terminal, yes. So, and that means learning Git from the command line, unfortunately. And by the way, if you want to learn, the true way to learn Git is Git tutorial. This is how I learned. This was suggested to me by some people on the stream, and I cannot thank them more. In fact, there was stuff in here while we were going through it that really senior Git veterans didn't know about, like Git switch, for example. And so if you want to really, really get into Git, you can do that, but we are not going to do that. I am trying so hard to keep this at an easy level, and yet I'm already hitting problems on myself. So let's go ahead and get status, git status, git pull. It won't even pull unless I unstage the last change, which you can't do. You can't uncommit a change. As soon as you've committed the change, it's committed. You'd have to discard that branch and pull it down again to discard changes in the working directory. Yeah, it's really good. It's really well written too. Yeah, git log. It should not be this bad though. It should not be this bad. I mean, should we do a git pull dash force? I mean, I could do that. It will still fail though because of the thing. So if we do git pull, it still says no. It can't fast forward. So I probably have to change my merge policy. Yeah. Yeah, I know. That's what I was afraid I was gonna have to do. When you got tripped up? Yep. And okay, so are you guys okay with me showing in the brute force way? Yeah. You can do a git pull dash force doesn't work. Because it's still stuck fast forwarding. Git merge origin main. It's already supposed to be doing more merge. Okay, auto merging, refig conflict, merge conflict and readme, automatic merge failed, fix conflicts. Oh, I forgot. You mean to tell me they stopped doing? They used to do this by default. They don't do this anymore? When did they stop doing this? This is the one that produces the file with all the crap in it, and then they stopped doing that. This used to be the default. This used to be the default, and you would do a git pull, and you would get a file that had crap all over it. Apparently, they've made it so that you have to do it explicitly now. This is interesting. I'm really glad that I'm going through this because I was not aware of this change. That is a change. That's like a fundamental change from how I used to use Git. And there's at least one other person I assume watching this who just got surprised as well. Go to diff tool. I just use git diff for everything. So that is super interesting. I mean, I seriously just learned something now. So Git's default behavior, first of all, Git does not set a merge policy off the bat. So you have to pick one. Fast forward is usually the one to pick, but they also changed it so that it doesn't automatically merge the way it used to. And so you have to explicitly do that. So to do that, you're going to have to say, what was that other Git config we did? This is fast forward policy or something. So git merge and origin main or master. You should probably, mine's main by default. And we won't get into that. If yours is master, use master. If yours is main, and then get the changes, get the conflicts so you can fix them. In last year's boost, when I set up your Git. Yeah. That's what I'm saying. This is why we have to boost every year, man. Something changes every year. There's like, and that's why, you know what? Before I wasn't working through it with everybody. I was actually just saying, go do this. And some of these things I was unaware of because I didn't do them and they had changed. So from now on, we're always going to do everything together, because I want to hit all these changes and be learned as well. So dirt changes at file level. Yeah. Git diff is like awesome. Yeah. It's like, I'll change it to my Zettelkasten and git diff. I do it all the time. Nope, nothing in there. Git diff is a recursive diff of every single thing in the directory. So it's super good. I really love it. I've changed it so quickly you have to stay behind left, which is why, even though it's a beginner boost, we have to do a different beginner boost every year. You know? Yes, it does show them visually, colors anyway, on the text terminal. How the README status is? Yes, let's look at that now. Let's look at that. That's a good thing. Hard and not soft. I don't know. I mean, I don't know. So, wait, where's my thing? Boostlab. You see how it changed right into it? Because my CD path is set. My CD path is set to this. See, I have a CD path entry that goes here. People are wondering how come I can CD straight into there. Because one of the things in my CD path is Boostlab. So I can just CD to Boostlab. All right, so... yeah. Well, okay, so let's go to, we're in Boostlab, and now you can see all of the problems, right? Now, if it's just like one line, that's one thing. Raise your hand if you've had like a project you've been working on and it's got like 20 sections of this crap you have to go through. It is horrible. It's absolutely horrible. And when it does this, by the way, honestly, sometimes this is where I'll copy off the other one that I know that has my change in it. And then I'll do it, because otherwise you have to do this. You have to say, which one do you want? Okay. Oh, I want this one, right? And you leave it like that and you fix it. And now it should actually commit. And so now we can say, oh, look, you can do git merge abort, right? Git commit, but it's going to ask you about that. You have unmerged files. No, I don't. How come it says... Fix them up in the working tree. Add remove file. As appropriate, mark the resolution. Recommend. I don't remember this. I hate merging. I absolutely hate it. I thought I was done. Git merge abort to abort the merge. What does that mean? Oh, you have to add it. Git add readme. Okay, that's why. The commit didn't work because, okay, that should do it. That should do it. Okay. Yes. Git pull the merge the remote branch into yours. You use git commit to conclude the merge. Git commit, and it's going to say merge blah blah blah, right? And we'll do that. That's why I hate merges, because they mess up your git commits. Yeah, git status, git push, and then you'll see the history. It'll show. It'll fix it, but it'll now be clean. The reason I don't like merge conflicts is because of this. See that? You get, where's the merge conflict? It looks like it's not showing us the merge conflict. It should have. Change go to the programming language. Huh. I think it's omitting that one. Also, I need to get my GPG set up again. These other ones are not verified. No, I think I did. I think I blew out my git stuff. Anyway, it's not. Yeah. Yeah, I pushed it and it made the change. Yeah. There it is right there. For some reason, it's not showing the merge, which I find interesting. Oh, there it is. Oh, okay. I didn't go far enough. Okay. Yeah, for some reason I didn't go far enough. I'm wondering why these other ones are verified. I think these. Yeah, I don't know why. These other ones aren't getting verified. But that's not the thing we're talking. This little green thing, you want that eventually, but you got to set up GPG keys to get it to work. And we're not going to cover that at all right now. If you want to go read about that, you can though. Anyway, should we actually write some Go code now? I tell you what, let's take like an 8-minute break, and we'll come back and we'll write some Go code. The only reason we did all of this is because we don't want to lose our Go code. We want to be set up to have Go code. So, I mean, that was like what, an hour? What time is it? Yeah, it was like 4 o'clock. So we took 2 hours on that. We took 2 hours on Go and setting up Go and what we're going to do, and then how to get ready to code. So we will write some Go code with the rest of our time. I do want to take a break though. We're going to go till 6 though, so no worries there. Calendar is just bang cal. If you want to go look at that. But I'm going to put some music on for a second, and some Angry Old Man music, and I'll be back in like 5, 6, 7, 8 minutes. I'm going to pause the YouTube. Ready? Pause. All right, we're back. We got a little crazy. Listen to Last Resort from Papa Roach. If you don't know the song, you're just going to have to join our studio audience next time, or come to RWX After Dark, where things get really crazy. I'm not proud. I just have fun. I have fun with my friends on Twitch. Honestly, most of my friends are on Twitch. I hate to say that, but that's true. I know that's really pathetic. Anyway, let's keep going. We're going to do some Go coding now. For the last 2 hours of the day, I promise we will do nothing but Go. All right? So, if you don't have the following, pause the video if you're on YouTube and make sure you do, because we're not going to cover it again. You need a repos directory, github.com, whatever your name is, and then you need a GitHub account. You need to have an SSH set up for that. You'd have Git already set up for that. We spent the last 2 hours doing that. And you should have a README in here. You should know Markdown so you can take notes. If you don't know Markdown, you're gonna get really lost, but you can just follow along with what I do. And if you want to go look at the challenges we're going to be doing, I already told you, rdbxrob/challenges is where we can put those. You can put those in here in the boost. Now this boost lab is going to assume that everything is Go for now. All right. I mean, why don't we not do that? Actually, why don't we not do that? So what is this thing? Let's go read it. Okay. Okay. So let's do this. Let's cut this out. What did I just do, by the way? I'm going to tell you, I said a D, capital G, to delete it all. And I'm going to make a new directory called Go. And I'm going to cd into Go, and I'm going to make a new file called readme.md. And then I'm going to P to paste. I'm going to say the Go programming language, right? I'm going to join these lines up, J to join the lines. Go programming language. And stuff. All right. So I just did a little bit of reorganization. I'm still in the boostlab, but I'm going to make a directory called Go because I'm going to be putting stuff in other places. So you don't have to call it boostlab. You can call it lab if you want, and then just put all of your stuff there. In fact, let me just show you my personal lab. I have all kinds of stuff. Anytime I want to like just try something really quickly, I go into my lab, and I mean, I have Kate's stuff in here, and I, from Harbor, Kind, NodeUp. Anytime I want to just like randomly try a little bit of code, and I don't really want to make a full Zettelkasten entry for it, I'll go in here and just try different things, just to kind of to test different things. And that is, if you want to go to that lab, it's already Victor Rob lab. So my dot directory, my lab directory, and my Zet directory are the most important things, pretty much in my GitHub. I also have a CV, and I have an RDBX Rob, which is the profile one, and we'll do that later on the boost. We'll show you how to make your own profile. When you have a GitHub directory that's the same name as your username, that is used as your special profile. So when people click on your name, it's like having a website without a website. And you'll see that a lot, God, sponsorships are going up. That's awesome. Thank you for the sponsors, everybody. And I think, as you can see, this is summer. This is my IRL streaming. I got kind of like soft, I guess. But I think this is more important than a website. And we're going to do that after the Go programming and after the web programming. We're going to cover this. We're going to cover how to make your own persona and profile on GitHub and how to market yourself and all that. But that's later on in the boost. All right, so we're in the lab. I just want to show you that lab thing really quick. So we have a Go directory. Now, the hard part about this is that normally when you're writing Go code, you're usually writing it from the outset as a module. So it's almost always going to be, like, for example, it would be github.com. Let me give you an example. My Bonsai. So Bonsai, this is a sample Go project, right? You have rdbxrob/bonsai, and you have your your readmes and stuff, and your Go mod, and we'll do all of that. And then subdirectories, subpackages, and stuff like that. And it's all kind of at a top level inside of a Git repo, but not always. And so one of the important things we need to cover right off the bat is how to organize the code in a Go repo. Now, this is a really, really deep rabbit hole. So I am not going to fully go down that rabbit hole other than to say that normally a Git, for beginners, let's say for beginners, you need to go to sleep. If you have to go to sleep, go, and you can come watch us later. For beginners, the best way to think of this is that the top level directory of a GitHub repo itself is either a Go program or a Go module. Okay, but we're gonna kind of completely ignore all of that for now. I feel dirty ignoring that, but I want to tell you that that's why we're ignoring it. We're going to ignore all of that for now, just so we can learn Go, so we can learn how to program, and we can learn the basics, right? And because of that, we're gonna be taking liberties with what goes in here and stuff about and how to run it and everything. Okay, so have a great stream, you too. Or have a good night. So I just wanted to put that out there. All right. So we have two files in here. We have this Go programming language README file, which you can use to write your own notes about Go programming, right? And then we're also going to have actual Go code in here that you can run. And the programs that we're going to be running, again, this is for beginners. So the first phase of this is going to be just running Go code as if we were running Python code. And I want you to know, though, that when we do this, it's not going to be the same as you would see out in the wild, right? But I think it's super important that you understand that Go code can just be run from the command line. And then we can move into some of the other things, okay? So much like we were doing with Bash. And let's take the first program. So the first program on our challenges list, continue your discussion. Thank you. So we're gonna go to the challenges. Let's go find them. Kind of like a Python interpreter, but not. We're not gonna make it. It's not an interpreter line, but we're gonna. Let me just show you. Okay, so there are several ways to run Go code. All right. So the first way to run Go code is to just run the code like from a file. So I can run like foo.go, actually, and oh, damn. Do we need to cover setting up your Vim editor to do Go code? Shit. That's going to take like an hour. It is going to take an hour, I'm afraid. All right. I just realized that's going to take an hour. I don't want it to take an hour. Yeah, but you know what? This is if you're with me in person, this is exactly what we would run into. So, all right. So I'm going to exit out all my tmux windows, and get into my Boost lab. Yeah, it is. It really is a must. It really is a must. So we're now in the Boost lab, and I'm going to restart my tmux from there so that every time I make a new directory, it's here. See that? So now all my stuff is, every time I make a new one, it's here. And I exited out of everything, exit, and then I just did tmux and it restarted from the directory. It's actually a good practice to do that, because then every time you make a new window, you're in the same place. You don't have to like, re-cd around. Okay. So in order to do any Go programming, you have to have, I think it is. I personally think it is. But you can make your own decision. I do think that, yes, tmux is essential for DevOps. So we already did vim config, and we talked about this 2 weeks ago. So I'm not going to spend a lot of time on it. And if you don't know anything about this vim config, go back and watch 2 weeks ago, which would be what, week 12? And something like that. What are we on? 15, 14, 13. Okay, 13, 12 or 13. And we did tmux all last time. But if you go in here, you need to have Go in here. So if you're going to code Go from the command line, you absolutely, positively have to have this line in here. If you don't have it, it's virtually like useless to try to do this. All right. And I'm going to put this in our notes here so you can see. Covered. I'm going to put this in here. So, and by the way, all the stuff I'm doing right here is all tmux cut and paste, which I covered extensively last week. And, if you're not practicing, you're not going to get it. So I'm going fast and stuff, but that's because I'm assuming that you're practicing some of this stuff on your own. I don't use code completion. Yeah. I might try it, but I don't have it. If you have the link to the plug, you can let everybody know and they can try it for themselves. But I don't like that. So this is absolutely essential to have in your vimrc. If you don't have that in your vimrc, you're going to be very, very sad. And I don't even want to get into all the reasons you're going to be sad. The other thing that you need, I believe, is that you should set, and I already covered all of these, but there is an entire section in my vimrc of default settings that need to be changed for Golang in order to not be annoying and to get the colors that you want. Okay. I covered this already. I covered this 2 weeks ago. You can go make sure these lines are in your vimrc. That's all I'm going to say about that. All right. So pause the video right now and get all that working before you go forward. And if you think that's annoying and you don't want to use the terminal for your development and you just want to use, Goland or any of the other, graphic IDEs, that's fine. But I want you to know that this is what we're doing here so that you at least know how to recreate it if you want to. All right. I'm a huge command line fan for all the reasons I've talked about before. So add the go.vimrc configuration settings. Now you can spend like an entire Saturday afternoon just reading about vim config for Go, but just make sure you go and you run the Go install binaries, otherwise you won't get it. So everybody, we had somebody complaining the other day actually about Go, and there was, it was, oh no, it was not somebody. It was in a blog I was reading, and it said it was so annoying to do imports. I'm going to make a case for why you should do this. All right. So let's make a hello.go. Let's do the first challenge. So if you go, we're going to go to the challenges, and we're going to read the first challenge. So hello challenge says, create a program named hello that prints hello world. All right. So, and there's not much more there. Let's do this one. So you'll notice that because I'm using Vimgo, when I opened up a new file, hello.go, it automatically populated the file for me. I didn't have to type anything. And by the way, if you exit, it will not be there. It will still not be there. You have to like save it for it to be there. But I want you to see a few things. So the first thing is every single Go file must begin with package. And there could be a comment in front of it. We'll get to that. But otherwise, it must begin with package. Now, people who slam Go all the time are like, why does everything have to be in there? I don't like that. I want to have my imports down at the bottom, blah, blah, blah. Do you know why they did that? So that they can make Go the fastest compiling language on planet Earth without any objective disagreement to that. Go is hands down the fastest compiled language on the planet. Rob Pike's obsession above everything else with Go was that it would be a faster compiling language than C. And that meant doing things that annoyed him for years when he was doing macros and stuff. Because macros have to read the whole file. Sometimes they redo the file. It was as annoying, it slows all of compilation down if you've done any C. And they don't get done right and everything. So he dictated that the language would say, you must put your imports at the beginning. You must put your packages at the beginning so that the compiler can, it makes it easier for the linker. Yeah. And so the compiler and the linker can go to the top. The compiler that's actually, it goes through the top. After it gets past the imports and stuff, just to do linking and stuff like that, it doesn't have to go beyond that at all. It doesn't have to look at any of the other stuff in the file. And that is a significant difference from any other interpreted language where you can declare anything at any point down below in the file. So the package has to be the first, and import has to be like the very first thing. You can't put an import down here. If you put an import down here, it'll fail. Right. So if you save that, like, nope, can't do that. You put it up here, right? Hey, thanks for that. And it has to be up there. Okay. So, and like Java, if you know Java, every program that executes from the command line must have a main package and must have a main function. There's no exception. If it's going to run on the computer, it has to have main package and it has to have a main function in the main package. This is the same as Java. I think C++ as well. But I mean, you can write all kinds of functions in there, but they're useless until something that has a main exists that imports all of the other stuff. All right. So this is actually importing FMT, which is the standard print. Some of you may have noticed that I did another print. I did print align, and I'm going to teach you this one as my debug. Hello. So println and print are actual, what's the word I want to say? They are part of the language. You see how they're green? They're not imported. They're leftovers, by the way. They're vestiges. This is actually a good way, if you want to put stuff. It's actually better to do log.println if you want to do any kind of debugging. But what I wanted to show you is that you see how when I saved my program, it automatically added the imports. If you have not set up Fatih's Vimgo, go do it until it does this. Otherwise, you're going to be going nuts. Watch what happens when I comment this out and I save it. :W to save. And the filters automatically remove that line. The person that was complaining about Go, their blog goes, I hate that it doesn't let me use unused imports, because they don't know about the filters. They're like total script kiddie. So if you put this here, same with that. It gets rid of the import. It cleans the code up for you. That's actually, there's a thing called FMT imports or something. It's one of the many things that's in the Fatih Vimgo plugin that when it's enabled, it will do the right thing. And I promise you that one thing will save you hours. I'm going to do it again. Okay. And now it writes it all there, right? So there you have it. All right. So this is the beginning of a program. You have a package main. If the package name is anything else, that'll be used for imports and stuff. We're not going to get into that. We're just, for the first, probably this week and the next 2 weeks, we're not going to do anything except for main, right? And by the way, if you're using Python and you think, oh, Python doesn't make me have a main function, it actually does. Anytime you write any code in Python, the implicit function wrapping the code in there is main. It just does the wrapping for you implicitly, and Go makes you do it explicitly. Go mod init, you don't need it. We're not going to use go mod init for this. As I said, we're going to be doing Go coding that doesn't have anything to do with go mod init and any of those great things. We do need to go this, but I don't want to hit people with that early. We're going to do stuff without go mod init. So that means, this is the first way to run Go code. Now, what I'm about to show you is almost never used in production. You almost always, Go is a compiled language that somebody compiles somewhere to run someplace, like C or another language like that. We could talk all day about that. But right now, is it Go instead of Rust? All the kids on TikTok use Rust. Yeah, who don't have jobs. Oh, snap. Yeah. I just read all about Dagger, which is all, and etcd and a bunch of other stuff that's been written in Go. Nothing significant has been written in Rust, period. We're not going to talk about that. Okay, so we'll do go run hello.go. Hey, look at that. It ran. All right. Now, if somebody out there who knows Go is going to give me crap about saying, but that's not how people use Go. Blah, 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 blah. Calm down. Calm down. All we want to do right now is get people to know the syntax of Go who may have come just from Bash or Python or JavaScript or something like that. Obviously, the goal here is to get an executable that can just run by itself. It doesn't have to have Go run, right? And believe me, there's people who have actually made it so that they can run Go code like scripts with the shebang line and everything, which still runs faster than Python, which is super amazing. Doesn't matter. I would never do that. So I just want you to see that you can do go run hello.go and it will run. All right. That ran just fine, right? Now, let's do something that is more akin to the way people would normally do it. Let's turn that thing into a binary. And so this is where go build comes in. Go build. And we got to put these in our lists. Go run. Hello.go. And then we're doing go build. Right? Hello.go. Go build. Hello.go. Oh, and you see what it did? It made a program named hello. Right? Now, there's going to be somebody out there who's going to say, but you forgot the -o. You don't need it. If I wanted to name it something else like hello, then, oopsie. I did it wrong. It needs to be like this. Hello. There. So if language is superior, it's the best language for the job. It's not the language you like. That's the problem. People who like languages, like writing like WebAssembly, imagine making a website in C because WebAssembly lets you do that. Wrong language for the job. Right tool for the job. Yeah. Anyway, so if you want to, you can add this -o, but why? You really don't need it, right? If you keep the name the same, then you don't need to do that. You'll notice though that it made a file that's red and got this X on it, and you know what those are, right? RWX. X stands for runnable. So we're gonna remove the hello because we don't really need it. And how do we run it? It's just hello, right? A little bit of a quick test. Oh no, my program won't run, Mr. Rob. Why not? Come on, this is a little bit of a review. Why won't my program run? Come on, you know it. I have a program there that compiled and it won't run. Why won't it run? A little bit of a review. Nobody wants to say, yeah, it's not in the path, right? Well, no, we already did go run. We know that works. It's not in the path. Okay, so let me ask a more specific question. How do I run it at that spot without moving it? There we go. There we go. There we go. It doesn't need a chmod. That's another interesting legally. Thank you for noticing that. Okay, so it's definitely ./hello. So the first thing I want to know, thank you very much for your comments. These are very useful comments. So I'm glad you mentioned that thing about chmod plus x not being needed, about chmod plus x, because we did talk, it's not schmox, by the way, it's chmod plus x. Schmox is my thing. And if it's a script, remember the steps when we did bash scripts, we had to do schmox or chmod plus x to make a file executable. Well, when we did go build, it made an executable file for us. Let's look inside of it through the magic of VI. Let's now look inside of this file. Try to do that with your VS Code. I dare you. I dare you. I might have gotten better at it, but not too much. This is one of the things I like about you guys. If you accidentally open a binary file, it tries really hard to do the right thing. And we're actually looking at the binary guts of an ELF executable. What else looks like this? Oh, I don't know. You guys remember the ls command? What? This has an ELF at the front of it too. Yeah, I can do hexadecimal if you can. It's really cool. So the point I'm trying to make is this hello file is an executable, but not just executable, it's also a binary just like ls or any other system file. That is really, really significant because that means that file doesn't have to have Go installed to run. You want me to see? You want to see what I mean? Watch this. So how do we run the thing? It does have strings, yes. It does. And people know me know that. So in order to run it, I have to run ./hello for safety reasons. Right. Why? Yeah. So here we go. This thing can run, but here's the magic. Here is the absolute magic. Do you remember how I was talking about I have this new set of computers over here, right? Well, what if I want to run my hello program over here on this other computer over here? I'm going to copy this one file, this binary file as is, over to my Mac Mini that's running Ubuntu server. And I can copy it over there and I can log into this machine and I can run, let's go see if it's here. Oh, we got different colors and stuff, but I can do ./hello and I can run the program with no changes. Which Go? There's no Go on this computer at all. I want to pause for a moment for you to realize how amazing that is. Whether you're an operations person or you're a programming, yes, I do for the most part. It depends. I mean, it depends on what system I'm on. So I want you to pause and understand what it means to not have to install any libraries, install any programs. It's installed. It was compiled for Linux. You want to see something even crazier? I want you to just see this. Okay, so this is that program, right? So I'm going to show you these things because this is the strong distinction between a shell script or Python or Node or anything else. This is the reason that so many Fortune 500 companies are converting their entire code bases to Go because of its cross-platform compatibility. Rust has the same thing, by the way. So what we're going to do here is I compiled it for the default architecture, which is what? So let's learn another command. Go env. All right. Binaries are bigger for sure because they're statically compiled. If you know about programming languages, the reason the hello world is pretty damn big because it's binary compiled. That same code in C would be a few K, maybe. Right? Because it puts the entire Go runtime in there. Now, if you do that same thing in Java, it would be like 10 megabytes. So I mean, it's okay. The way that what they've done is they've just Very, very, very small binaries. Oh, hell yeah. She's going to be the winner on that block for a very long time. Yeah, it is a very strong reason to use C. I mean, there's lots of great reasons to use C. Efficiency, memory sharing, IPC. I mean, C's not going anywhere. But you got to understand that Go is designed to be a level above C. By the way, Go is 100% compatible with C. You can write C code in Go and compile it, and it will work. We're not going to do that today. That's not a beginner thing, but that's another one of its. The reason that there was a 4,000% increase in Go malware in 2021, according to, I think, Bloomberg, was because you can take existing C malware and encapsulate it in Go and blow out all of the malware signatures that are defined to look for stuff. And this is why so much ransomware is written in Go. Hackers love Go for the reason that I just showed you, that you can compile C, you can encapsulate it, it's super easy to write, and you get this binary that you can run anywhere. Now, here's where it gets really, really fun. Okay, here's where it gets like crazy, crazy fun. So see, use modern C and C++ and not C. Yeah. So this Go program, so here's our challenge. We did that already. I can get rid of that. So let's do Go env. This is going to show us all the environment variables that are set for Go. Now you can override these environment variables. We covered environment variables 2 weeks ago in Bash. I'm not going to cover them again. You can set them up in your Bash RC. And you can see that I'm using Go version 1.18. We haven't even installed Go yet, and I just realized that. So let's just keep going on with the Go sales pitch, and then I'll show you how to go install. Those of you who don't know how to get Go on your system, there's like at least 5 different ways to get Go these days. However, if you are on Go server, let's do it right now. I feel don't let me forget to talk to you about cross compilation though. Okay, so let's do installing Go. I feel so bad because I didn't show you. All right. Somebody needs to yell at me next time. Install Go. Yeah, you need to know how to install Go. It's go time. I never did. All right, so if you're okay, one of the reasons that I picked Ubuntu is this. So here is my mini is on Ubuntu. Yeah, watch this. If you have the latest Ubuntu server, which I assume you do, this is why I do a boost every year. Then the only thing you have to do to install Go is sudo apt install -y. I think it's Golang. I don't know if that's the one or not. Yep, that is. And that's it. We're done. Cannot run Go in the browser, no. No, not without a terminal. Go is a command line thing. Yeah. Now, this is going to install all of Go. I kind of wish I hadn't bloated my endpoint, but oh well. This is one of my machines over here. These little Mac Minis over here. I inherited like 19 Mac Minis from my SKILSTAK school community, and I turned those into a cluster. So that's what that is. While this is compiling, I'll just plug that. I've got another playlist called Home Lab Init, and all it is how to set up your own home lab to do Kubernetes and DevOps and hacking, and specifically how to write software for infrastructure engineering applications, operators and Kubernetes, stuff that, distributes stuff better than Ansible and that kind of thing. So that is a separate playlist, and we'll cover things like better SSH config and pushing and everything. All this information, this is all coming from my Mini. That Mini 1 says I'm logging into that machine down there. I don't know if you saw how fast it is, but these are all raw. These are not VMs. And I'm super happy that I didn't go with Proxmox. Also covered in that if you want to watch. Go play around in the browser, but it's not the same. No, you can, but it's not the same. Yes. All right. So, Nick Shelpedo, if you're on Nix, I'm not. Ubuntu server is what I recommend to people. So, I don't even recommend Red Hat these days. So it's up to you. Make your own decision. Anyway, so here we are on here, and I can say, go-version. And actually, there's no dash. It's just version. It'll tell you you're going by 18. Here's the thing. Don't learn with anything less than Go 1.18. Somebody going to yell at me for saying that? There's before Go 1.18 and there's after Go 1.18. Go 1.18 is one of the biggest milestones in all of Go's history since like 2013. It's not just generics. Generics is like a major part of it, but there was so many other things. In fact, Go 1.18 was originally going to be Go 2.0. And then they included all the backward compatibility stuff and they reworked it and it's Go 1.18. Workspaces, generics, workspaces. We're going to use workspaces right now. I cannot imagine using Go without workspaces. And we're gonna definitely cover workspaces when we get to imports. We're not there. So believe me when I say, don't install or learn anything but Go 1.18. How about the any keyword instead of interfaces, instead of the empty interface? Just that alone. 1.18 is the only Go that exists as far as you care. And anything before that, if you're forced to learn it or look through it, fine. But learn 1.18 first and then learn about all the other things that have changed since then. Trust me, you will be so much happier if you do that. So I'll go 1.18. So yeah, I mean, it's like sudo apt install -y golang. Make sure Go 1.18 plus. Yeah, you can 1.19. 1.19 is even better. Yeah, they put some great stuff in that. But at least have 1.18. All right. And I mean, you're going to run into a lot of stuff, but I'm just telling you, it's going to be so much. I'm going to teach some of the stuff. And we will, I don't know if we'll learn generics or not. We'll try. I don't know if generics are a beginner thing, but there is, if we're going to do, I wonder if we should do a linked list just for fun. I'll have to think about it. I mean, there's some traditional computer science-y kind of data structures and stuff that we should probably incorporate into our projects that we don't have a lot of them in there. And I think we should incorporate at least one to show off generics, which you can't do in other languages. So, I mean, you can, but it depends on the language. So anyway, all right. So we're in our lab and we have Go here. And okay, so back to, I showed you how to install. It wasn't that hard, right? There is another way to install. The other way to install without getting too deep into that is to go into, was it user local? And to just extract it and just put it, extract the zip. But I'm not, no, pretend I didn't say anything. just do Ubuntu server. Look, if you're not using Ubuntu Server 22 or lighter, you're not going to get Go 1.18. If you're using Red Hat, you're going to get an old version of Go. If you're using Arch, you probably get an old version of Go. I don't know. Yes, it does. It adds Go itself to the path, but it doesn't add your binary to the path. And remember the difference between, it'll run Go because it'll find it in username Go, right? But your program is not going to be run because it's not going to know about it. Arch has 1.19. Nice. That was fast. That's the default. All right. Well, so whatever. The boost we've been doing Ubuntu server because it's more employable. Blah 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 blah. If you want to use Arch or you want to divert, that's fine. But just know that's fine. Okay. So it can't find hello. All right. So let's first of all talk about how to automatically put that binary into our path. Right? So you could do Go install, right? And then what? Cannot find main module but found git config, blah, blah, blah. Oh, we can't do a Go install because it doesn't know it's a module, right? But we won't, let's skip that module thing, right? For now, we're going to skip that module thing for now. That is normally the right way to do it. But we know that we can just do a Go build and that'll make us, oopsie. go build hello.go. And that will build one binary for us, right? And we're going to quickly outgrow this because we're going to want to have multiple files involved. But I just want to show you that you can do it. So now you have a binary, but the problem is that the binary isn't in your path, right? Now, if you have my fancy thing, prepend path or path prepend, which you should have, we covered this in our bash thing. You can say path prepend dot slash, and now you can type hello and it will find it. And that only applies to this window. If I go to a new window and I type hello, it's like, I don't know where you are. Path prepend dot slash. And now anything in here, I can type hello and it'll work. And that is a trick that I've been doing for years. Sometimes I actually want stuff to run in the current directory, but this is a safe way to do it because it's not the default. Right now, if I put that dot slash in my bash recipe, that would be a bad idea because it would always run whatever's in the current directory, and that's really, really dangerous. So don't do that. But for this, I can get away with it, right? Another thing I can do. What else can I do? I can copy that binary into my path. So let's look at my path. My paths are all pretty and stuff. I covered this 2 weeks ago. I'm not going to cover it again, right? VIC path. If you want to see my path program, there it is. We covered that a couple weeks ago. But I don't want to do it again. So any of the, if I put, you see how a dot slash is there now? But if I want to put any of that in here, if I want to put it in any of these locations, it'll run. Now it's not really a script, so it doesn't really go there. How about dot local bin? Ooh, that looks good, right? Let's do that. So if I copy or if I move that hello file into dot local bin, right? Then even with my path doesn't have dot slash in it, it will still run. Why? And if I want to see which one it's going to run, I do which hello, and it will show me that it's grabbing the one in my path, and it shows me which path it's using. So the moral of the story is that we have, when we do go build, we get an executable file that can go anywhere in your path on any system with or without Go installed, for which it has been compiled, in this case Linux, and you can just run it. And that is the great, wonderful glory of Go, because you can do that. Now, by the way, it did this way before Rust did it. Rust uses LVM to do its cross compilation. Go did it without doing that, and it did it way earlier. So because it did statically linking, I don't want to get into it. But let's say I want to run it on Windows. And this is, again, one of the reasons I have Windows, because I want to show you. So I want to compile it for Windows this time. So we can do this. We can say go, is it Arch? Which is the one that lists all the Go architectures? I can't remember. I'm tabbing. I mean, I think we can do go build -h and go see. No, go help build. I don't remember which one. One of them shows you all the different architectures, and I'm trying to remember how to list them. I have a thing that does this already. Go version doesn't show you Go version just shows you the version. It doesn't show you the current dist build. There we go. All right, so I wrote a script. I'm going to go cheat. I'm going to show you a script that I wrote because I can't remember the exact command. So I wrote a command called go dist build. And this is why I taught we went through bash first. That's it. Go tool dist list. Yeah, thank you for that. That's exactly it. Let's put that in the list. Yeah, that's the one I was looking for. Definitely. Thank you. Go tool. I gotta give you some AR for that. Yep, that's the one. All right, so go tool dist list. This will tell you. Thank you for that. That's the exact command that will show you. All of the different architectures that you can build Go for. Now, the difference between an interpreted language and a compiled language, roughly speaking, I mean, there are so many caveats to this. Java is compiled, for example, so this is totally blown out of the water. Pizza's done, by the way. Pizza's done. Oh, my God. How much longer have we got? My wife made pizza. It's just sitting there tormenting me. So Go. These are the different things that we can build for. And as you can see, there's a lot of them, right? The difference between a binary, an ELF binary, and an ELF. There's two types. Generally speaking, there's two types of things that run on computers, right? There are interpreted things that have to have an interpreter, Python, Node, JavaScript, Ruby, right? And then there are languages, Java, and then we talked about this before, but we're going to talk about it again. And then there are languages that do not need an interpreter. So there are interpreted languages and non-interpreted languages. The interpreted languages are generally convenient because you can write them and everything as long as you have the interpreter installed. Bash is interpreted. Z Shell, Lua, all interpreted. But actually, no, Lua is compiled as it's embedded. Anyway, C is compiled, right? So with the non-interpreted languages, you get a compiled binary that only runs on a specific architecture. And by architecture, we mean, this version of Linux for x64 versus ARM, right? Or Windows, and here they all are, right? Solaris, Plan 9, OpenBSD. These are specific hardware chip architectures. And when you compile without an interpreter, if you want to run code without an interpreter, you have to run one of these. And now the interpreted languages, the interpreter is compiled and run and for one of these target architectures. You have to install Python for OpenBSD ARM, for example, right? In order to just take your generic Python script that you wrote on a Mac and then copy the file over and run it. Now, we've talked about this before, but since this is kind of a new series on Go, I want to kind of go over it again. Interpreted languages have to have an interpreter, think C3PO, that has to take in the language, convert it into machine code or whatever, and hand it over to R2D2 to plug into the Death Star, or do something else with it. It needs that interpreter, and it takes longer to do that, and it's a pain in the ass. But we do it because we want to just be able to write scripts really quickly and spread them out all over really fast, right? Compiled code generally is harder to write, or in the past it has been. And one of the great revolutions of Go and to some extent Rust as well, is that in Crystal and even Java a little bit, is that these languages, compiled languages, are getting as easy to write as the interpreted language. So the benefit of an interpreted language is kind of going away. The quick speed to delivery, the developer velocity, all of that's kind of going away because people can write compiled code for a specific target operating system as fast and efficiently and with far fewer bugs using Go because of its strict typing. And we're going to get into that later. But the cross compilation is the thing that just when I saw it, my jaw dropped to the floor because I had been using Perl to deploy an application that was doing system auditing for which I could have got a dozen patents if I wanted to while I was at IBM. And I had to compile that code sort of using something called Indigo Perl, which would take the Perl code, bundle a Perl interpreter, and every time you run it on Windows or whatever, it would extract the whole thing and then run Perl with the interpreter, and then it would take the results and bundle them up and send them back and throw it all away. And the inefficiencies of that are so enormously huge. It's just not even, but it allowed us to take that one thing and distribute that to all of our clients, and it would just run and it would work. Even though it was, an interpreted language, we would ship the interpreter with it. And Python virtual environments, that's what they exude. It's exactly what they do. It's what a Python VM is. They ship the entire thing. Java does the same thing. Java lately, not always, but Java has been bundling the JVM that's going to run the Java code because they're not sure what JVM is going to be on the system. And so they'll bundle that entire thing with it. It's so amazing. The Rob Pike's Go Assembly Talk. Thank you, Dr. Byrne, for mentioning that. That's absolutely phenomenal. So when I show you this list of all of the target architectures that you can compile, the real cool thing, and this will be lost on beginners, but the real cool thing is that I could be on a system that can't even run the binary that I'm about to make. And I can make a binary for that target system without even having one of those systems in my possession. It's called cross compilation, and it is the most crazy, amazing thing ever. And it's possible because of static linking and stuff that we'd have to get into C code for you to understand. But the bottom line is I can do this. So if I see a tools list here, I can do this. I can say go arch equals Windows, right? And I can do go build hello. Oops. And oops. Go os. It's os. I did it wrong. Os equals Windows. I think it's going to use the same thing. It used AMD 64. So this first one here is the go goose or goss or whatever, GOOS, and then the other one is the go arch, right? And it will assume your current one, right? So if you do, like go env grep arch, you can go look up. So we have go arch, go host arch, and you can grep out OS, and it'll give you your stuff. It'll show you what it's going to goose. Goose and Gork. Are they really? I know you like to pronounce things that probably shouldn't be, so I'll accept your input on that. So he says in his talk it's Goose and Gork. All right, well there you have it. There you have it. I'll forever shall refer to it to Goose and Gork. So anyway, here we go. So go build hello. Package hello is not in. Oh, it's trying to build. Oh, wait. So I got to do go build. Oh, hello.go. Right. And it implies the name. Now, why is it taking so long to build for Windows? Anybody want to know? My fan just came on too, by the way. Why? Because Go, when you do this, Go in the background has to download all of the libraries, the binary libraries for Windows. And once it caches them, then you can build anything from it. It'll actually go much faster this time. See how much faster it went this time? It went a lot faster this time, right? If I were to do Mac, let's do Mac. I supported, what was it called? Darwin. I think it's Darwin. So let's do a Darwin one now. See, it takes longer because it has to download all the binaries for Darwin. Now I do it again, it'll be a lot faster. Right. So, and by the way, this hello, look at this. Watch if I check the file type, look at that. You remember the file command? So you remember that hello program that we used to run? No. Watch, I'll move hello over to temp, and then we'll do it without this, right? So let's just do go build hello.go, and now we do the file type on hello, even though it's the same exact file. Now we have a Linux ELF binary that's a statically linked Go program. But if I do the same thing on the one that was there before, I get a Mach O. This is like, this is Darwin stuff. This is like a Linux thing. I mean, a Mac thing. So I can SCP that file over to my Mac and run it. Now, the Windows one has to have an exe extension for it to run because Windows. So you look at it, you can see this is exactly what kind of file it is. And the cool thing about that is I can actually go out of this. And let's see, let me open a new one. So let's open a new terminal. It's a new Windows terminal. Again, this is on Windows. It looks like it's on Bash or Linux, but it's not. This is running Git Bash on Windows. This is 100% Windows. See ya. And so now I have all these stuff over here, right? All these exes and stuff. So let's copy over. So I'm, again, as I said, I'm on a Windows system. The videos I've been saving are here. I mean, I just want to prove to you that I'm on a Unix. I mean, I'm on a Linux, a Windows system right now, even though I'm using Git Bash, which is my preference over WSL because WSL is way broken. So I am going to copy that file over. So I copy Anton. I'm going to say I want hello.exe to here, and it'll copy it over. No such file. Oh wait, actually, this is one of those cases where I'll like dump it into temp because it's faster for me to find. So let's do that. Let's go back to I'm back on Anton, which is my, VM. And now I'm going to move hello dot, just because I don't want to remember the path. I mean, I could just type the full path, but that's a pain in the butt. So I'm just going to move, I'm not doing explorer dot, no. Because I'm going to move, it's because it's a VM, my friend. So we have to do a copy. So we're going to move hello.exe over into temp. All right, so it's not there anymore. So back over to Windows. So now we're on Windows, SCP Anton, which is my Linux machine. Temp hello.exe, and we're going to put it right in this current directory. And now you see we have it, and we can say there is no file command on Windows. Oh, there is. Oh, that's, what? Is that a bash thing? Oh, wow, that's fantastic. That means that git bash provides the file command, which is so great for hacking. I can't believe it. Anyway, so as you can see, it's a MS window file. So I can actually run hello, and it can't find it because it's not in my path. If I do /hello.exe, I can run it. I think I can do it without the exe. Yeah, there we go. So, and I don't know about the path environment variable here. I don't know. I guess not. I don't know if I can actually. I'm curious. I've never tried this before. I'm going to try this. /, and if I type hello, will it do it? What? God bless git bash. God bless git bash. All right. So my path command is not working for some reason. Oh, that's because it was a command and not a function. Interesting. Okay. So yeah, but if I echo path, you'll see it's there, right? If I echo path, I don't want to do that right now. No. Type. Yeah, anyway, so it did it. It did. So I can run exactly the same program over here, right? And I don't have to make any changes. So I don't know how much time we got left, but that is one of the big reasons. We have an hour left. We have 45 minutes. Let's do something like rm-rf. No, let's not. That won't work anyway, you know. No, it gets trapped all the time. Yeah, I have to prove that to everybody every time. So we're going back to Anton here. Let's go back to Anton. We're on Anton now. And so we have this slow program that won't even run. Promise me. Wait, what? Oh, no. This is the Mac one. Cannot execute this file because it's not a Mac. I'm wondering. No. Because the Mac Minis are no longer Mac that I have. I have Mac Minis, but they're not Macs anymore. They're Linux. Different operating system. So I'm kind of thinking I might want to put one of those Mac Minis back to being a Mac and then SSH into it. Just for like Mac compatibility tests and stuff, you know? I'm having a moment of contemplation. I do have a MacBook Pro. I mean, I have a Mac Pro and a MacBook Pro. I'm wondering if I should maybe put Mac back on one of those endpoints that I have. I'm sorry, I'm having a little moment of home lab contemplation. SKILSTAK differences. Yeah, we're not going to talk about SKILSTAK right now. Max on download binaries and resource. Yeah, I know. I made my K-login. I made my K-login for Kubernetes, and they just download it, and they have to go in and approve the executable. It's annoying as heck, but yeah. But yeah, I mean, that's the point. So there's a hello world. You just refresh your MacBook Air for compatibility testing. Yeah. Yeah, I think I'm probably going to do the same thing myself, actually. I mean, I got 19 of them. No, you know what? I could do my. I have a what's the Mac that has the built-in screen? I have a Mac with a built-in screen on it. I should just use that because then I can get to the screen as well for compatibility. I should put that back in my lab. I have a Mac Pro as well. I should probably just leave that up. I also have iPads, yeah. I have all that stuff. iMac. Yeah, I have an iMac. I have an iMac and you can't really put Linux on there. It's not, no, it doesn't. Okay. Anyway, we're spiraling out of control here. But I have a ton of Mac hardware, including like 3 Mac monitors, Thunderbolt, which they completely abandoned and left me with $1,000 a pop. I'm super sore about that. I lost so much money on that. I lost like $10,000 on that. Buying those, they deprecated them like the next year. Anyway, back to Go. it must have been time for a break. What time is it? It's a time. You know what? We should go 50 minutes at a time, and then we can take a break and have a piece of pizza. All right. So, how about I have one piece of pizza and we come back? You ready? All right. This is a 58-minute Pomodoro, so let's do that. We're gonna come back. We wrote our first Go program. We installed Go. What else did we do? We have talked about the main function. We learned the 3 different ways to run programs, and we will also learn about how to make modules, which is a little more complicated. So let's do that. Let's go ahead and take a break. Here's some more music. Oopsie, that was kind of loud. I have to step away though. I have to step away. So time, I tell you what, I'll only take 6 minutes this time. Turn down 6 minutes. If you're watching YouTube, it'll be like an instantaneous thing. Bye. We're going down. Okay, we're done. Put the recording sign back on. There we go. All right, another break. Another Go to now. So we've got our first Go program. And believe it or not, you have successfully written your first Hello World program. Hello World, right? And I mean, just for now, you can just go run hello.go. Now, if you really want, you can actually split your screen and use ENTR, which we talked about doing before. Do you guys remember how to split your screen? Control A dash if you're using my tmux rc, which I talked about last week. And so now I have to go into the right directory, and I can use the ENTR direct file, which we've done already, but I can use ENTR to run the program. And I can just say ENTR bash -c is usually easier. And I don't remember if I have to, but yeah. And here we just do go build. I mean, this is better because you can put semicolons and put lots of different things. If you do bash, these easier. So you go build. Actually, no. Go run hello.go. Right, and we need to feed it a list of files that have changed. But in this case, we only have one file, so we can just send it hello.go as a string. And by doing that, sorry, then it'll just run hello world. Actually, let's clear the screen. So every time there's any change to the file listed here, hello.go, run the program. Right. So now I can do hello.go, and I can come up here and I can say hello other world, and I do save :w, and it will run the other program. So this way you can set up like a method for running things. And in case you want this thing, I'm going to copy this out with tmux. By the way, how did I do that copy? So I'm doing Control A, left bracket, space to start selection, $sign to go to the end of the line, and then enter, and then the numbers will go away, and now that's in my buffer. So I can go back to the other window. So is this Control AA or Control A1, wherever I am. Okay, 2 maybe. Here we go. And then I can add that command here. And so I'm in insert mode down here, you can see, and then I'm going to do Control A, right bracket, and that will paste in the code from tmux. Backticks around it so that it will show up in when it's rendered as text nicely, even though I don't need that for YouTube. And you can see that that's going to help you run your Go program. All right, so it's a good way to take notes. I'm kind of doing the method of taking notes that I recommend you do. I'm just happen to be doing it in my show notes as opposed to your home lab notes, but might be good for you to, to put that in here in your README. And I think we already have one of these open actually, don't we? Oh, what is this one? Oh, this is my program. So let's change this one. Let's say, what do we want to say here? We want to say coding. I did Control A comma in my tmux to ask me what name, because I want to know what window that is. And the second window is this one. We should put this one should be boost. I should put the boost README, so boost. And 3 3 is nothing. 3 is just us screwing around. So I'm going to close that. I close it using Control A and then Shift 7, which is the and sign above that, and that shuts down my entire window, all the panes in that window. Otherwise, you have to close each pane. It's kind of annoying. All right, so then we go to 4 and see what's up there. Nothing really there. So again, Control A and then Shift 7 to get rid of that. So now I just have these two, and I can go back and forth, and then I have this one. You can't see the line very well, but there's a separation between those, and it's no longer running because I turned it off. But let's go run it again. So now we have this, and I can change it up however I want, and hello, let go, and it'll tell me what's up. Okay, so a couple of things to talk about here. So the reason that we did bash already, so is so that you would get familiar with the concepts of variables, strings, functions, and that. So you should already be familiar with those concepts from bash, which we did before we did this. All right. I think it's really important that you understand that, because otherwise you're going to get confused with how is that printing? What is it doing? Blah, 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 right? So I'm going to break down this main program one last time, and then we're going to move on to the next one. So this is a package. Everything in Go has to be a package. The package main run. It imports a library, a package as well, that contains its own functions and other symbols, which includes other variables and things like that. Now, you should know what those are if you already went through bash. What's my channel for what? YouTube? So anyway, when you go here, we can do fmt.println. So there is no println. If I tried this like this, it's going to be like, no, sorry, can't do it, because there is no println here. Now, if I made a println function in this same exact package of main, it would use it, but we don't have that. So we put fmt in front, and then it imports that package and we can use it. If you've done this, programming in any language is the same, whether it's JavaScript or TypeScript or Python, or they all pull in other stuff that somebody else made, whether it's standard or otherwise, to use in your own stuff, right? And that's what we're doing there. And you can change this up and save it, and you get it to run. So as I said, every function has to have every main program has to have a main function. Now, this in the strictest sense, if you're a mathematician, this is not a math function. It isn't giving us anything out. And in that case, I would call it a subroutine or a procedure. In fact, in Python and Perl and several other languages, Pascal, when something just executes a number of steps, and that produce some behavior without strictly speaking returning a value, it's generally referred to as a subroutine or as a procedure. And in the case of Go, because of compilation speed, they went ahead and kept the keyword func. I think that was a huge fail on their part. I think they could have went with def instead. One of the reasons I like Python so much is because they're very pedantic about their terms. I hate Python for most things these days, but one of the things that they do really well is they're really, really pedantic about terminology and keeping things that are understandable for beginners and that apply. So in Python, this, instead of having a func here, it would be def, right? It'd be def main. And the reason I like that is, and in Perl it's sub, and the reason I like that is because, and in Go it's fn, is because it's not a function. It's not a function. A function is a thing that returns a value that has no side effects and all the other great things. I mean, if you know anything about lambda calculus, which you should eventually understand a little bit about in order to understand how computers work, because they do lambda calculus essentially, you'll know that at the lowest level, every computer does nothing but functions at the lowest level. And every time we add on stuff that has side effects and gets away from that, it makes it easier for the humans involved, but it's getting farther away from how computers actually work, which kind of annoys me, because this is not a function. At best, this is a subroutine or a procedure, and I just want to say that. Okay, I mean, a true function here would be this. A true function would be this. It would be add one, let's say, right? So add one, and they use mixed case. So add 1 to x, and we'll make x an integer. I mean, this might look familiar to you, right? But if we're going to have a function, I'm kind of jumping the gun, but whatever. So, and then I could do this. I could say return, x plus 1. That is a function. I mean, that is a true function. And you kind of have to say that now. You kind of have to qualify it these days. You want to say it's a true function. If it's a true function, as opposed to just a procedure that's a function, is the main Go routine. Yes, and it is the main Go routine, right? So yeah, and we'll get into Go routines and concurrency at some point, hopefully, but not right now. We're gonna do when we do our story game, we're gonna make wandering monsters, wandering events, random events, and they'll be on a separate Go routine, concurrent thread. So anyway, function add 1, that is a function, right? So, and you can combine them, right? So you can combine. You can say hello world. Plus, it could say FMT, and there's also a printf instead of println that lets you. We're going to use a lot with this, but that lets you put these in your notes however you want. If you do %v, that will print out that thing in its most popular format. And you remember this. This is very much Bash. We were doing stuff like this, so I just want to show you that it also exists in Go. So then we could say x. We could say add 1 to 10, right? And that there's too many values apparently. Add 1 to 10. Have too many return values. Oh wait, what? What did you wrong? Oh, I didn't declare it, of course. Yeah, if you have a return value, you have to declare it. So I have to declare that there's going to be an integer come out of it. So now it has 11. Yeah, thank you. So, and if I do another one, right? Now you can do this too. And this is lambda calculus right here, but it's kind of hidden. And now we're writing Lisp. now we're writing Lisp per closure, right? It gets really hairy, but those are upper. I mean, that does take you down a computer science path that is probably best avoided for now. But I just wanted to show you that it's not a function, and I wanted to tell you why. Actually, a procedure / Go routine. All right, so you can see that. So the idea of a function is, just like in Bash, that you can write it and then call it. Now, the important thing I need to tell you right off the bat is that you should probably default to lowercase function names until you need to allow somebody else to use it. And we're not going to even go into that for several weeks. But so for right now, just stick with mixed case. That's the way to go. Ha! And you'll see this one is a capital P, and spoiler alert, that's because it's exported. And Go does not have an export keyword. It implies exported symbols by being initial uppercase, which is very unorthodox and awesome if you ask me. Some people hate that with a deep abiding passion. I love it because it saves me from typing export all the time. But that's what's up. That's why that one's capital P, because it means that, I mean, anything else, if there was like a println in there that wasn't capital, it would only exist within the scope of that package, and it could never be used by anything else. And that we'll talk about variable scoping and all that stuff later. That stuff is not particularly relevant when you're talking about Bash, because everything's either global or nothing, right? I mean, there is the local keyword. We talked about that in the function, which makes it so you can just type in but for the most part, no. All right, so there we go. That's our hello world. So let's go back to our challenges and see where we are. So, that we covered that. We covered the hello challenge. Print hello world. Now, the reason that I have a hello challenge is because the hello world, if you go search the internet Hello World history. You'll know that Hello World is a cultural phenomenon for coding. It has been around since forever, and it is a really great way to to check whether you've got everything in line to even write any code at all. So that's why it's there. And I don't know if you noticed, but just to get hello to work, we had to install Go. We had to talk about compilation and how to run the program. We had to talk about environment variables and architectures and all that stuff. So Hello World, as simple as the program is, I think is essential because it's a great catalyst to determining, whether all of your plumbing is working, right? This down here, it also gave me a chance to talk about ENTR. So now our plumbing is all working, and now we can start to do things that are more involved and interesting. But I just know that Hello World is a thing. So there, we've introduced functions, we've introduced return values. These are all things you're going to have to look up. We're going to play around with several different types of return values. In Bash, you'll remember we only had numbers and strings, and we're going to start with that in Go, but there's actually, you can make your own types and all kinds of fancy things with Go. And we probably won't get into a lot of that initially, but eventually you'll want to do that. So we've accomplished our challenge. Okay, our challenge is done. Good, hurrah, we did that. And so put challenges there. So let's do the next one. Let's make an interactive introduction. This is much harder. Does anybody know how to do this one? Say hi to a specific person. Actually, I think I had this one first. Let's do that one. That's actually let's do that. This is a little bit easier. All right, so let's make another program. Let's make a program called hi. And again, we're going to make it from scratch. We're going to make it from scratch because we want to repeat the stuff that we did in the last one so that we remember it, as opposed to just, spitting it out because we already know it. Please fight the urge to copy and paste at this time. At this time, you want the repetition. It's deliberately in there to reinforce what you did before. One of my biggest gripes about Free Code Camp is that Free Code Camp is a accomplishment without repetition platform. You'll finish one level and you'll finish the next level and you'll just beat the level, and you really don't care as soon as you beat the level. There's no repetition. There's no building on it. There's a little, but there's not nearly as much as there should be. So please take the time to write it out. I could do this. I could do hello.go and copy it to hi.go. That's the efficient thing to do, right? And change it to do whatever I want to do and modify it, right? But I'm going to suggest that you don't do that, that you actually start with a new file, hi.go, and it'll maybe help you out here. In fact, maybe even get rid of that stuff, right? You can turn it off, but maybe delete all of it and say, okay, I'm going to go for broke here. And I'm going to make a brand new file. So what's the first line? Package main, right? Okay, we're actually going to hit a problem here on purpose, which I want to hit. All right, so then we're going to say, we don't need that, so we can do func main, right? And fmt, let's start by, what does the requirement say? Say hi to print to a specific person with a default. Okay, so println, hi Rob, or something. Right. All right. Let's see if we can get that to run. Go down here. By the way, I did Control A J, and that put me down there, and do Control A K to go back up between my panes. That's what I'm doing. I'm gonna go. I just did an escape. So Control F bracket and then up arrow in VI mode to go here. Enter bash.c clear. Go run hello. We want to change this to hi now, and change this to hi, and it will say hi Rob. Okay. Nice. All right, so that's running and all right. But what can we do differently here? We want to say hi to a specific person. All right. Well, what if we want to pass that person from the command line? And that's what the requirements normally say. It doesn't have it right here, but I think we have it in our RWX stuff. Do we have it? Yeah. So if we do, hey there, hi you. I mean, oh damn, that's right. I moved all that stuff. So it says, if it's passed an argument, then say hey there or hi there over there. Okay. So how would we pass a variable to it? So we need to pass in a variable. We want to make this Rob thing somebody, right? So right away we know we need an print F, and we'll do V. We know we have a V, and we'll say name, right? But I don't know what to do after that. What would you do after that, right? And we have an error now because it says undefined name. So this is where we get to introduce variables. So we talked about variables in Bash. You should already know them. But variables are a way to save off something, right? Now, variables in Go have a very specific scope. If I put a variable up here with the var keyword, then that says that anything in the entire package can use that. If I put it down here, it means that only the main packet, the main function can use this in this particular program, right? Only the main program in this particular file can use it if we're going to do go run. So that is, the nature of scope. And we have to decide, well, so generally speaking, it's a bad idea to make package globals because they can be stomped on. So we'll go ahead and put it inside of the main program. Var name type. Yep. So the first thing you need to understand is that in Golang, things are reverse notation, and there is a really great blog. Let's see if I can find it. Golang Pike blog on reverse notation. He geocoding. No, that's not it. Go declaration syntax. Yeah, I think this is it. Newcomers to Go wonder why the declaration syntax is different. So I'm doing all that searching from a separate window, like we talked about doing. I hope you're practicing doing these things. I talked about how to do this for an hour last week. So I'm going to go ahead and add. I want to add this blog. So Control A. No, wait. I need to type D for links. I'm typing D. Wait. Is capital D? I thought it was. I can't. Oh, it's A. A-D. I want to add this document. Golang declaration syntax. I'm going to add that to my bookmarks and links. And then I'm going to go add it to the boost stuff. So I can come over here and I can do bang bang links A, and that will pull in the bookmark and tell you about Go's declaration syntax. Terminal DuckDuckGo searchy thingy. Oh, yeah, I covered it for 2 hours last Saturday. Go watch that boost video. Yeah, it's in the boost video last week. So let's go ahead and read Rob Pike's thing on this. We're just going to read it directly. Newcomers to Go wonder why the declaration is different from the traditional established C, and is supposed to compare two approaches. And it's very verbose, and he talks about, but the main reason is because there are things you can't do when you do it the traditional C way. Specifically, you cannot combine this right here, this kind of crap. You can't combine two arguments of the same type with a comma. And so the reason that he considered it and eventually changed it and used this particular notation is because it compiles much more efficiently. And it's those little things like that Pike obsessed about, which made Go the fastest compiling language on the planet. So if you go here, you see it gets kind of messy, right? And yeah, I mean, if you really want to get into the whole thing, you can go read about it. But it does talk about certain situations where you can't even do it. It's reverse Polish notation in Golang. So, art to make technical sharing. It's reverse Polish notation, I guess, is what it is. Yeah. Anyway. Oh, maybe that's something different. I don't know what that one is. I'm going to close that window. So that was Control A and sign, Shift 7 to close my window. I'm going to continue to tell you what I've been typing as I type it. So let's go back into the challenge. So we have a name. We need a name, but that's not going to help us. When we run it right now, what does it do? It just prints hi, but doesn't really put anything out there, right? There's nothing there. Well, let's give it a variable, right? So we can say name equals Rob by default, and you'll see it says hi Rob, right? Okay, so this is the longhand notation for variable assignment. And actually, one of the people who was complaining about Go recently, that in a blog that I read, they don't like that there's more than one way to do this, but it's one of the things that I love the most. The shorthand of the same thing is what's called a walrus operator, and you can get rid of the var. This only is possible in local scope. You can't do this in the package global scope. But if you do name space equals, and it will actually imply the type. It will imply the type as being a string, and you don't even have to declare it as a type. And you see how that works down there. Now, seriously, there are people who freak out over all of the magic that does. But I'm here to tell you that kind of magic is what makes a very serious, compiled, strictly typed language like Go feel like Python. It's not Python, but it feels like it. Oh, thank you. Oh, thank you. Don't lock her in. But so this is a huge win in my book, right? It's a huge, huge win in my book. But there are a lot of people who really, really hate that. And by the way, strings in Go must be wrapped in quotes. And I hope you're, taking some form of notes about this in your Git notes or something the way you want to. You can take your notes however you want. So there we've got it. We've got it printing out a default. Instead of us saying Rob though, let's have it say hi there. How about that? Hi there. Hi there. So if there's no, we want it. I mean, the challenge was we want it to, say hi to a specific person as an argument. So how would we take an argument here? Right? And that's something we'd have to go search. So let's go search it. Passing arguments, command line arguments to Golang. I know how to do this, but I'm going to simulate you doing the search. Command line arguments in Golang. Let's go read about it. Command line, let's start. So let's actually add this to the document. I'm adding this to my notes because I want it to be in my notes, whether they're your notes or in my notes here. I'm going to bang, bang, links A. So again, my notes are going to be the show notes for YouTube, but same for you. It could be just your README file. I'm adding that link there because I want to link to that so I don't lose it. And I used my little script that I wrote and we talked about last week for looking at the links bookmarks file at the end of the links bookmarks file. So let's go back to our links and read. Let's start writing some programs in Go that will allow us to pass command line arguments for running the program. It's really easy and allows us to pass custom arguments for running Go program. We will create our custom arguments as well. Just to recap, what's an argument? And what's the difference between an argument and a parameter? Okay, so I'm going to hold Control N to kind of eke down the file and eke down it and read it. Working with command line arguments. So here, these are all different types of arguments, right? This is an argument, and this is an argument. So then it introduces us to a package like the FMT package for printing. There's a package called OS. And this is where the args array is stored. Now, the args array automatically gets all of the args that were on the command line as they were separated by white space. They're called fields. And there's actually, in the strings command package, you can actually use separate by fields, and you can chop up things as if they were arguments if you want to do a similar method. So as you can see, we can go look down at our example here. Again, I'm RWXing this, right? So, okay, here's our main program. Ooh, look at this. Program name. The first argument is always the program name. Okay. OS args 0. What's this about? Okay, well, it says it's always an array, right? So let's read about what an array is. Golang array. If you want to do if you want to go through the tutorial and go through it all, you can, but I like to do it this way. Golang arrays with examples. Let's go look at this. In this tutorial, we'll learn about how to store multiple arrays. Introduction. An array is a data structure, consists of a collection of elements of a single type or a simple one that you can have a special variable. We already know arrays because we covered them in Bash, but let's read about it. The values of an array holds called elements or items. An array holds a specific number of elements and it cannot grow or shrink. Did you hear that? That is a big, big, big deal in Go. Arrays cannot be changed. They're not ephemeral. They're immutable. That means they cannot be changed. You have to make a new array. If you want like a combination, you have to put the two arrays together and then you get a new one and throw away the old ones. Right? That's really important because there's another type that we're going to get to that makes this life of ours easier in Go. Different data types can be handled as elements such as array, int, string, and boolean, and others. The index, arrays in Go are immutable. Slices are not. All right, and that's really important. In fact, it's so important. I'm going to put it in the because it's probably one of the biggest differences between Go and other languages. Arrays are immutable. Slices are not. Yeah, well, we're about done. I know you guys have to go. What time is it? Yeah, I'm going to be here for another 15 minutes, but thank you for joining us. This will all be on the YouTube if you want to go watch the end part of this. So, yeah, I don't think... You know what? I don't think arrays are immutable. I think I misspoke. They're of a specific size, but they're not immutable. No, not like Rust. I think I might have got it wrong. I got that wrong. In fact, I know I got that wrong. They're different. I should just put arrays are different than slices. I don't even think they got this right in this thing right here. You know what? Let's do the research. Because nobody deals with arrays. They deal with slices, but it's worth looking up. Immutable struct and Go. Immutable structures. Struct fields are immutable. Constants are immutable. Go makes them easier. Oh, no, I guess not. Go's are primitives, though. No, they're immutable. But they have to be exactly the same space. Yeah. So nobody uses them because they're, you can't resize them. You can't add more to them and stuff like that. Data structure consists of a collection of elements, single type. We can know more than one value at a time. And the values of an array holds are called elements. Right? This is the one we were on any other page. I found the same one again. Oh God, it's just doing reflection too. I mean, this is not for beginners. Reflection is a package that helps you, from the outside look in at otherwise would be hidden types and stuff. It's very slow, and you don't want to do that unless you're just doing debugging of thing. So The thing of it is you can change the type, but like if you put Canada in there, it's gonna blow out that extra space for you. Yeah, I should look at arrays more closely myself. As a beginner though, you don't really need them. As a beginner, you just use slices and you're fine. Yeah. Yeah, here's an arraylet. Literal partial assignment. Yeah, okay, you can. Look at that. Bar y equals it, blah, blah, blah. Print x plus y. And with ellipses. Yeah, this, I thought I wanted this. At first, I thought I wanted this because I thought I wanted to just have it be a thing. If you're going to use, yeah, if you're going to array, yeah, up front, if you're going to do that. I mean, that, and that, if you know C, that might be something you'd be interested in doing. So this one, for example, allocates 5 bytes, 5 ints, and then assigns the first one and the third one to these numbers, but then you can actually change the other ones in there. If you're a C coder, you're really going to like arrays because they're going to feel normal, but to the Python and to the Ruby and the other people, they're going to hate them because they're not what they think. They think it's not a list. Let's put it that way. It is not a list. Thank you for the follow. They are not lists in Python, right? Because you can't change them. All performance languages have this. Have slices versus arrays. Does Rust have slices and arrays? Java has it, but I think they call it a vector instead, right? I don't remember. What is Java's equivalent? There's like the low level array, and then there's the higher level. Yeah. And you can definitely do it. And there's ways that, these are not beginner topics, but there's definitely ways that you can like pre-allocate an entire data structure so that it already has that much memory assigned. But again, this is supposed to be a lot of people's first experience coding, and they don't even know, really what an array is. It's just a list. It's just you got a whole bunch of things there. So, yeah. And yeah. You can create a copy of an array by assigning an array to a new variable. Yeah. You have to create a copy if you want to do it, though. Interesting. What's going on, Rob? That was weird. I'm kind of interested in this. I want to read it some more. Check if the element exists. Yeah, no. Anyway, so the absolute beginner takeaway here is you probably want to slice and not an array. That's all I'm going to say about that. When you do the pointer thing, it's not a deep copy. No. I mean, no, because you have pointers anyway. And we haven't even got into pointers. I don't want to confuse people. Y'all are more advanced than the average beginner here. So all you need to know is that os.args, which is what got us on this, is got a bunch of stuff in it. That's where we're going to get our name. See? So we just want to see the first item. Or we don't want the 0 item, right? Because what is that item? The 0 item... So we want to get the argument. So instead of there, we could say, let's change it to be os.args. I'm doing it wrong on purpose. Uh-oh. What happened? What happened, everybody? Look down here. And if you'll remember from Bash when we did it, anything that executes in a Linux environment, and actually to a certain degree Windows and Mac, I guess, the first argument is always the thing that was executed. And as you can see, Go dynamically builds an executable called hi and runs it. It's doing that every time we do Go run. So it's kind of doing that for us, but it's not what we wanted, right? we want it to be the first argument. So let's actually change our little thing here. We want go run hi.go, but we want to be able to pass an argument to it. We want to be able to say, Rob, right? And it's still doing hi, right? Well, what happens if we change it to 1? Okay, yay, that's what we want, right? So now we have it printing out the first argument, but there's a problem. What happens if there's no argument? Uh-oh. And let's look at this error. This is a panic. Panic means we've done something that normally would be really bad. Now, the first thing I want you to understand is that out of range and memory, errors and stuff that people do in C are not even possible in Go at all. You can do some memory buffer overflowing, but it's not at all like the traditional that you would think with C. Go is very much protected from that kind of stuff. You can still do it, but it's much harder to break and to do that kind of thing. So when it says index out of range, yes, it is a problem, but it's not the kind of problem that's going to allow us to inject malicious code at that place in memory. But just be aware of that. It's still, we don't want it to panic, right? What we wanted to do is we wanted to have we want to have a default value, right? And so let's go ahead and do that. Let's change this for now. And let's change it back to there. So now we have hi there, right? And then let's add, we're gonna go ahead and add back the this other value if it exists. Okay, so this is where a really common idiom comes in, and you say if. So we learned if statements from Bash, but so if the length, and there's no brackets around the if statements. So if the length of OS args, if the length of OS args is greater than 0, 1, 0, which one should be? It's 1, right? Because the length is always going to be 1 because the first item in the list, index 0, is always going to be the name of the executable. So if the length is greater than 1, actually, if the length is greater than 1. Okay, so how many we're not talking about the index, we're talking about the length. Right? So if we do 0, we're going to get a problem here, right? I'm going to show you why it's a problem. And we put brackets. So then we say name equals os.args. And we want args1, right? Uh-oh. Why did it panic? Because what is the length, right? The item number, the item index 0 is there, and that means there's at least one item in the thing, even though it only has an index of 0. So we're going to change it to 1. Yeah. So the length is exactly 1. You could say if the length is exactly 1, if you want to be more precise, that's definitely a solid way to do it. If the length is equal 1, equal to 2. Because why? Because again, we have to have that first item. We have to have, watch, if I put 0 in here, watch what the name becomes. Let's get rid of this. All right. So remember that os.args, in fact, if you want to debug, let me show you a secret for debugging. A secret for debugging is to use the log. You can do log print, right? Do log printf. This is a fantastic way to debug. Log printf, because then it's going to go to standard error and everything. And then you can say, I want to printf all of os.args. I just want to see what it is. Right? And you can just do v like that, and it'll print it out. And you can see, it'll show you. So when you do log, it actually puts a timestamp on it. But as you can see, it prints it out, and you see that there's one item in the list, right? If I go down and I put it up in the list and I put another item in here, you'll see it'll be 2 items. So we have, this is index 0, and this is index 1. That means that %v is, if you've ever used printf before, it's just printf, but it says to put it into whatever its stringable form is. That's all it means. So if it's a number, it's a number. If it's a string, it's a string. It's just a convenience. We'll go through all of printf eventually. It's really powerful, particularly when we start to do binary stuff. You can change it to binary notation, all kinds of things. So it's just a way. I mean, you could probably just do this actually for that one. Let's try it. Yep, same thing. V just means variable, yeah. You could do S, but S says that it must be a string. And the difference is that if I wanted to do, I mean, the reason that, I mean, okay, so first of all, if you print anything, it'll automatically marshal it into a stringified form if you do print, right? But if you want more control over it, you can do printf. And the reason I use V is, let's say I want to do length args. It's for debugging in particular. So if I want to put a 2 there, right? But if I have an S here, it'll blow up. It'll be like, nope. And this, by the way, this exclamation point that means that you've got an error in your format string in printf. That's what that means. That means you did it wrong. And it gives it a good shot and it tries. But if you put V there, I mean, if I put N there, obviously it's going to work, right? Actually not N. It would have to be, no. It had to be, what? No, I'm just going to have to do V. It's got to have to be L probably. No, is it L-I? I don't remember which one. I don't have, is it D? Digit, okay. Yeah, it's the good old printf stuff, right? But I've gotten so lazy because all you have to do is put V. V will do the right thing. V, no matter what it is. I mean, you could, here's a fun one. B, it'll print it in binary, base. And you can change the base too. Yeah, if you want it in binary, it'll do it in binary. So it's, I mean, seriously, the log printf, the printf function, and there's a FMT printf and there's a log printf, are the same. They're very, very powerful for debugging, particularly if you use print for debugging, which I do all the time, always have. But what I was trying to show you is you got these two things here, right? And then you've got, so the logic here is actually, if the length of the arguments is 2, or if you want to, I mean, that's very precise, right? But if we want to be a little loosey-goosey about it, we could say if the length of the args is greater than 1, then it will work, right? Is it 1 or 2? It's greater than 1. Oh, yeah, it's supposed to be 1 here. There we go. No, Go is object oriented, but not class oriented. There's no classes. No, it uses a better organization for that. We're going to get to that, and not anywhere soon. They have structs, and then you can hang methods off of structs. So, yeah. Well, I mean, this boost is for something different. We will be learning JavaScript a little bit later. There's lots of ways of doing that. All right, so we're doing the tail end of the boost, and we're doing Go programming right now. So, but yeah, those are great questions, by the way. I'm gonna make a plug again for this. So if you do Cal, every weekday these days, from 6:30 to 7:30 Eastern, is that right? Did I get that right? Is it 5:30? 6:30 to 7:30, I think. We do questions, conversations, and 6:30 to 7:30, yeah, and advice. So if you want to come back during then and ask the same questions, I'd be happy to answer them. But right now we're focused on getting this coding done. Okay, so anyway, so here we go. We got length of args. So if it's greater than 1, the reason I like this one is because and as I said, if somebody puts 2 names here, right, it'll still just get the first one. Why? All right. So how would I make that do the whole thing, by the way? I have to wrap it in quotes, right, to make it a single argument. Now it'll do hi Rob, you'll see. Right? So, I mean, you can make your decision there. I mean, another thing you could do and is you could join them all together. Anybody want to try that? How would you do that? Maybe we could do that as extra credit. How would you take all of the arguments after the first one and squish them together into a string? How about that? You want to try that? Let's try that. We're going to do color next. Yeah. Yeah. I don't know if we're going to get to a day, but... Oh, it's 6:04. Yeah, we got to end today. So next week, we're going to start with color. So that is on... we're going to do greet, and then we're going to do term colors, and you're going to be making your own library for terminal colors that are supported on any color terminal created since 2012. So and then we'll have a lot of fun doing colors and all kinds of things. But the last thing I'm going to put a challenge out to you here. But how could you combine all of the arguments so that you have a name that has them all combined? I'm gonna put that out there, right? So how about this? So we would do fix me, make this combine all arguments into single string. Okay, so I'm gonna put that out there as a challenge. I'm not even gonna tell you how to do that. I know, but concatenation, yeah. But I want you to figure it out. All right, and when we come back to this, we can cover that. But I want to leave you with a challenge, something to work on your own, and we will start the day on Friday with that. And I know it seems like we're going slow right now, but there's a lot of little things. There's a lot of ways to do this. So I've heard a couple of good suggestions out there. There's a lot of ways to do this, different methods, and you know we have gone kind of slow, but you know, that's the point, right? And so I'm going to commit all of this code. So let's go ahead and do that final thing, and then we'll wrap it up for the day. I'm going to go ahead and kill this. So Control C and then exit from that window. Clear this window, which is also C in mine. I just typed C and it does it. And let's go ahead and save the code that we added, right? So that was the whole point of going to all that hassle with Git for the first 2 hours. So let's make sure we don't forget that. So the first thing you could do is git status. And say, wow, okay, it looks like I've changed a lot. I've changed the current directory. That means I've added stuff to it, right? And I've also modified this. So let's go ahead and use that trick that we talked about where it just adds everything because we've got a lot of changes, right? So let's do this trick here where we add everything. Git add -a space dot. So let's do that. So let's make sure we're in the top level of our directory. So we got RWX raw boostlab go. Oh, okay, I got to go up a level. All right, let's do git status again. Oh, wow. Okay, so now we can see what we need to add. Now, you could individually add each of these and make a commit for each one if you want to do it the right way, or you can just add the whole thing. So I don't know. Let's see what we did change. So let's do git diff, and we'll talk about that. Git diff to see what changed. So, okay, so I got a new program here in this README, and I have this new file. So there. Okay, so it looks like I reorganized. So it looks like one commit is probably going to be fine. So let's do that. Git commit, git add -a dot, and git commit, and it'll show us everything that got changed. Now these things are showing up because I did a search for that. That's why it's doing that. So let's go first time and say, and we're going to say if you apply this patch, it will what? It will add hello and let's see, add go dir with hello and hi and initial high challenges. I mean, I know that's a long one, but and no period, and we're just gonna hit enter, save, and we get status again. I do get status all the time. It's like, oh, I forgot to push. Okay, git push, and we'll go git push, and now get status, and we should see it's all clean. And we can go to our site, wherever our code is, and let me see if I can find it. Boost Lab. And What's up here? Okay, 7 minutes ago. Oh, look, there's my commit history message. Okay. Ooh, look, it shows me everything that changed. That's pretty cool, huh? In case you make a mistake, go back and see what you broke. Click on that Go directory. And you can go in here, you can click on your code, and you can see it here. You can't run it from here. If you actually go to Git pod, you can do stuff like that, but we're not going to do that. Or if you, there's ways to, what is it? If you like type dot from here or something. Yeah, if you type period, you see how I typed a period? Did you see what I just did there? If you're browsing in your Git stuff and you type a period, it will open it in VS Code Online, and you can go in and you can use the editor here and do all of your editing this way, and you can save it. I obviously you can't run it from here, at least I don't think. There's no way to run it. Yeah, this is just VS Code Online, but I don't know if I would do that personally. I mean, if you want to review it and have it look pretty and everything, it might be cool and all. And especially if you're editing README files, you know, and thing. Yeah, does it have console down here? I didn't think it had a console. I don't think it has a console when you do it online. Can you? You can open a console? Normally the console's like right here. Oh wait, what is it for console? It's I want to say it's comma. Oh, it's yes. That's right. I remember now. Terminals are not available in the web editor. To use the terminal, you'll need to continue in an environment that can run code, like a code space or local VS Code. Well, there we go. I didn't think you could do the console, which is the whole point. So, I mean, it's cool and all, but I've never paid for it. Anyway, so that's good. We got our code. Our code is saved. Happy day. And we're ready to go have a good Labor Day. And with that, I'm going to go ahead and leave y'all. Thank you so much for hanging with us. And, go have a beverage, have some fun. I will be hanging out. I don't know what I'm going to be doing. I'll probably be playing games and working on my stuff over here and writing other Go code for other things. And Labor Day, I will be doing QCA tomorrow, even though it's a holiday. So be sure to tune in for that if you want to come by. And ask any questions that you might have. Otherwise, to the YouTubers, thank you for everything we're doing. If you feel like you have gaps in your learning and you want to, fill in the gaps there, we do still need to talk about that. That does remind me of something that we missed that I put on the list. So let's go back and look at that. So we did not talk about overview of learning landscapes in Go. We did not talk about that at all. And I want to make sure that we talk about that next week. So that if you feel like you want to dive in and really get dirty in there, you can do that. The short answer is I haven't found anything good online for learning Go. The last thing, if you want a quick answer because it's Labor Day and you want to work on it, the last stuff that I looked at was in rdvx.gg lang Go. And if you click on that, my feelings about this are largely the same. And although I tell you what, we'll talk about this first thing when we get back next week, because somebody's going to want something more comprehensive that goes through the whole thing. And I truly believe that reading the Go language specification, how to write Go, and effective Go are the three best ways to learn Go, short of making things, which is what we're doing. If you want exhaustive, and I mean you really want exhaustive, in other words, you want to know why the language is spec'd the way it is, you definitely want to write how to write Go code because it's a mindset change, and effective Go. All of these are free. The tour of Go is a great way to get started, but it's finicky. It's got problems. It's not designed for beginners. So I'm not a fan. I did Tour of Go for a while, and then I was like, nah, give me the docs. I'll be fine. So yeah, it's brutal. It jumps you right into. I am so disappointed with the TourGo. Not disappointed enough to suggest replacing it, which I don't think they would, by the way. I think somebody needs to step in and take over TourGo completely and change it. But I don't think that the powers that be would allow that to happen, personally. And there's a lot of professionals out there, which we'll talk about on the next week. Next week we'll start out by how to learn Go, right? Yeah, there's a lot of books, and that's why I think we should save that conversation for next week. There's like really serious errors in Go in action. And Go 101, no, I mean, look, so let's save that for next week. I'm going to make a lot of enemies, but I'm not going to make enemies in so much as I'm not picking a fight. I want to tell you what I like about them and what I don't like about them. And so far, personally, this isn't just a not inventor here thing. I cannot get behind any beginner Go resource that exists. Go 101 is pretty damn good though. So, and by the way, make your own decisions. Go read all of them, and then you'll make your own. You can make. But most of the people that go to Tour of Go get really turned off really quickly, and that's why I've tried to do some of these simpler things to get going faster. I did do a video on how to start a Go project, right? But that's a long time ago. There's the Golang resources guide, which you've seen if you want to go play with these. This is just absolute shit. I'm sorry, I should not say that. Okay, time for me to go. We'll see you next week, okay? All right, bye.